Ready? ¿Listos? Good. We are so happy, muy contentos de iniciar este primer Congreso Internacional. Okay, dear audience, it is our pleasure to initiate the first International Congress for the Study of Cognition and Behavior. In this first edition, we are going to discuss about experimental clinical psychology. The intention of this cognition and behavior study group is to share and create networks around the world with different universities and researchers. We want to share new findings in cognitive and behavioral science. We want to serve as a space for the dissemination of scientific work in psychology and related areas. The Cognition and Behavior Study Group, GECC, is a non-profit group made up young researchers interested in the dissemination and promotion of scientific work in psychology and related areas. We are honored to have the participation of excellent speakers. In this first edition, we have important researchers from Arizona State University, Washington University in St. Louis, Missouri, University of Minot, Université of Montréal, and Guadalajara University. We hope you enjoy this Congress so much as us. Thank you so much for being part of this event. Querida audiencia, es un placer para nosotros iniciar el primer Congreso Internacional para el Estudio de la Cognición y Comportamiento. En esta primera edición vamos a discutir la investigación sobre la psicología clínica experimental. La intención del grupo de estudio de cognición y comportamiento es compartir y crear redes en todo el mundo con diferentes universidades e investigadores. Queremos compartir nuevos hallazgos en ciencias cognitivas y del comportamiento, servir como un espacio para la difusión del trabajo científico en psicología y áreas afines. El Grupo de Estudio en Cognición y Comportamiento GECC es un grupo sin ánimo de lucro formado por jóvenes investigadores interesados en la difusión y promoción del trabajo científico en psicología y áreas afines. Nos sentimos honrados de contar con la participación de excelentes oradores. En esta primera edición contamos con importantes ponentes de Arizona State University, Washington University in St. Louis, Missouri, University of Minot, Université of Montréal y Universidad de Guadalajara. Esperamos que disfrutes este congreso tanto como nosotros. Muchas gracias por ser parte de este evento. Vamos a esperar unos segunditos para dar entrada a nuestro primer ponente. Let's wait some minutes before to introduce Professor Peter King. Dear audience, querida audiencia, one more time. It is our pleasure to initiate the first International Congress for the Study of Cognition and Behavior. In this first session, we are going to discuss research about experimental clinical psychology. The intention of the Cognition and Behavior Study Group is to share and create networks around the world with different universities and researchers. We want to share new findings in cognitive and behavioral science. We want to serve as a space for the dissemination of work in psychology and related areas. The Cognition and Behavior Study Group, GREC, is a non-profit group made up of young researchers interested in the dissemination and promotion of scientific work in psychology and related areas. We are honored to have the participation of excellent speakers. In this first edition, we have an important researchers from Arizona State University, Washington University in St. Louis, Missouri, University of Minot, Université of Montréal, and Guadalajara University. We hope you enjoyed this Congress so much as us. Thank you so much for being part of this event. Querida audiencia, es un placer para nosotros iniciar el primer Congreso Internacional para el Estudio de la Cognición y Comportamiento. En esta primera edición vamos a discutir la investigación sobre la psicología clínica experimental. La intención del Grupo de Estudio de Cognición y Comportamiento es compartir y crear redes en todo el mundo con diferentes universidades e investigadores. Queremos compartir nuevos hallazgos en ciencias cognitivas y del comportamiento. Queremos servir como un espacio para la difusión del trabajo científico en psicología y áreas afines. El Grupo de Estudio en Cognición y Comportamiento GECC es un grupo sin ánimo de lucro formado por jóvenes investigadores interesados en la difusión y promoción del trabajo científico en psicología y áreas afines. Nos sentimos honrados de contar con la participación de excelentes oradores. En esta primera edición contamos con importantes investigadores de Arizona State University, Washington University en San Luis, Missouri, University of Minot en Portugal, University of Montréal de Canadá y Universidad de Guadalajara aquí en México. Esperamos que disfrutes de este congreso tanto como nosotros. Muchas gracias por ser parte de este evento. En este evento contaremos con 7 ponentes y cada hora la oportunidad de escucharlos y tener 15 minutos de espacio de reflexión para hacer preguntas y platicar con ellos. Y tenemos una sesión de carteles de 1 hora donde podremos revisar 8 trabajos que nos enviaron para compartir su investigación en diferentes partes del mundo. Y ustedes van a poder entrar, ver los carteles y hacer comentarios a los ponentes de esos carteles. I hope you enjoyed this part too. Okay. Entonces, ¿cómo estamos en tiempo? I guess we are working, tenemos una red de trabajo junto con Lauren Ávila y Alejandro Rodrigo, quienes también están apoyando fuertemente y tal vez nos van a decir unas palabras también.
Buenos días a todos. Antes que nada, les agradezco la asistencia al primer Congreso Internacional del Grupo de Estudio de Cognición y Comportamiento, que, bueno, este grupo durante hace muchos años iniciamos, junto con el doctor Lauren Ávila, iniciamos este proyecto y poco a poco ha ido generando un poco de fuerza hasta el día de hoy, celebrando este primer congreso. Tenemos ponentes de la mejor talla y de la mejor calidad de todo el mundo, el doctor Peter Killeen, el doctor Joel Myerson. Vamos a tener también otros ponentes, algunos ponentes hispanoparlantes. Es decir, el congreso, aunque es un congreso nuevo y un congreso en donde apenas estamos iniciando, vamos a tener la participación de muchos ponentes de la mejor talla y de la mejor calidad, y creo que todos ustedes lo van a disfrutar muchísimo. Today, I'm very pleased to welcome everyone to this first International Cognition and Behavioral Study Group meeting. Today, we're very pleased because after a couple of years of working very hard into this new project, we're very pleased to welcome speakers from all over the world, but also speakers that are in the best way, like these speakers are the top of the tops. We're very pleased to have today Dr. Peter Killeen, Dr. Joel Meyerson. We have another couple of speakers from Spain, also from Colombia. We're going to have Spanish speakers. We are going to have some talks in English, some talks in Spanish. But I think we're here to celebrate and to congratulate everyone to join to this first meeting. And well, thank you everyone for coming out. I really hope that you enjoy everything. And well, thank you, welcome, and very, very soon we're going to start this meeting, okay? Thank you.
Well done.
Hi there again. We want to introduce you the Emeritus Professor Peter Killeen. He is a scientific researcher. He has written more than 100 articles. His work has been cited almost 10,300 times. Peter Killeen is an emeritus professor with the Department of Psychology in Arizona State University. Professor Killeen studies behavioral decision theory, statistical inference, and information theory. He asks questions such as how do we learn? How do we forget? What motivates us? How do we understand anomalies of motivation such as tobacco addiction? And how do we maintain attention? And why is it too hard for some people, such as those diagnosed with ADHD, to do so? How do we perceive the passage of time? How do we discount delayed or probabilistic gods? He studied PhD at Harvard University in experimental psychology. Professor Peter Killeen, thank you so much for your time, for giving us the opportunity to learn from you. And now in Spanish, queremos presentarles al profesor emérito Peter Killeen. Es un investigador muy prolífico, ha escrito más de 100 artículos, su trabajo ha sido citado más de 10,300 veces. El profesor Killeen es emérito por parte del Departamento de Psicología de la Universidad Estatal de Arizona. El profesor Killeen estudia la teoría de decisiones conductuales, inferencia estadística y teoría de la información. Se hace preguntas como ¿cómo es que aprendemos? ¿Cómo olvidamos? ¿Qué nos motiva? ¿Cómo entendemos las anomalías de la motivación, como la adicción al tabaco? ¿Cómo mantenemos la atención y por qué es tan difícil para algunas personas como aquellas que tienen diagnóstico con TDA? ¿Cómo percibimos el paso del tiempo? ¿Cómo se descuentan o se devalúan bienes demorados o probabilísticos? Estudió su doctorado en la Universidad de Harvard en psicología experimental. Y pues bueno, muchas gracias al profesor Peter Killeen por darnos su tiempo, por darnos la oportunidad de aprender de él. Thank you so much, Peter, for giving us this opportunity. We are so happy.
When would you like me to start, Diana?
I guess it's a time to start.
Oh,
you can
good.
share your screen and tell us all about you and your research.
Good. Can you see my first slide? Can you see? Okay, let me get down to see what I can do here on, oh, here we go. Remind me how I, on my screen, here we go, present now. Very good.
Perfect.
Thank you. Muchas gracias, Diana, Alejandro, Laurent behind the screen. This is a marvelous opportunity. That was a very kind introduction. I must say that one of my most important products will be with us later today. One of my first graduate students and one of my smartest ones, it was Joel Meyerson, who in this academic chain of parenthood, offspring is Deanna, because she worked with Joel also. And so we have this almost inbred conference today of the old man who is me, Joel Myerson, a bit younger, and then the lovely young Deanna Cruz, who is helping to organize this with her colleagues, Laurent and Alejandro. Thanks, this is fun. This is a good opportunity. I'll tell you what I know about ADHD. Let me start my slideshow. It's a weird phenomenon, ADHD. One of my desires when I was a young man was to become a member of the Institute for Advanced Study in Princeton, where one of my heroes, Einstein, spent most of his career. A dozen years ago, the good news, I was invited for a year to the Institute. The bad news is that it was not in Princeton. It was not in California either. It was in Oslo, Norway, which is very cold. Now, I'm going to give you a portrait of myself in Oslo. You can easily recognize me, okay? I'm the tall guy. The person on my left is Terje Sagbolden, who was the host of this meeting. The outside was cold, but the inside was heated by controversies of people like this. All of these are world experts in ADHD arguing about some details of the phenomenon. The guy on the sitting down, everybody's pointing at, is Steve Farone, and he was representative. You know, I might have 10,000 citations. This slide was 10 years ago. He had 60,000, probably 100,000 citations to him. So these guys are real experts, and I didn't know anything about. I was lost in the fog almost of this marvelous meeting. I took walks to try to clear my head and understand what ADHD was. Came upon beautiful crystalline lakes like this. But although this was a beautiful, clear thing, this lake, the concept of ADHD, I didn't have. I struggled to find it. Was it real? Is it overdiagnosed? Why is it? Is it a disease or is it a personality? Do drugs help? Do they harm? What do they do in the brain? Does behavior analysis work with it? These were some of my many questions. I was lost in the fog. It took me half the time I was there to begin to cut my way through the fog and try to understand what's going on. So what we're going to do is try to describe the thing that's ADHD, characterize the 4 causes of it, and I'll explain what I mean by that. And then introduce a new hypothesis of its material cause. So how do you describe the thing called ADHD? It's not easy. The Diagnostic and Statistical Manual, the latest edition, was in revision for 2 years to end with controversial recommendations. And the thing that held it up was the definition of attention deficit hyperactivity disorder. I'll explain in a moment that when I come into a new phenomenon, to really understand it, I try to describe the Aristotelian causes of it, which I'll talk about more later. And then I'm going to introduce the new material cause, hypothetical cause. It's an energetics hypothesis. It suggests that the cause of ADHD might be an insufficient energizing of the brain. And this helps explain some of the characteristics of ADHD. So Aristotle's 4 causes. He was mistranslated as these 4 causes, and people thought he was stupid. He was old and he was stupid, because how could you have a final cause, like the effect of something, be an efficient cause of it. Well, he wasn't talking. Efficient causes are one kind of cause. If you translated him correctly, he wasn't talking about causes. He was talking about be causes. What are the questions we have to answer to understand something? So the one we're familiar with is efficient causes, the triggers, what starts it. The material causes are what it's made of. How do kids with ADHD differ physiologically from those without? The final causes are the reasons or purpose or function. You know, if I gave you a schematic diagram of a 3D printer, but didn't tell you what it was a diagram of, the first thing you'd say, okay, well, what is thing supposed to do? So you're asking for a final cause, the functional analysis of the thing. And the question is a good one. What is ADHD supposed to do? Does it make sense to even ask that? All of these things are hard to ask and harder to answer, but they're all worth trying. And then by formal causes, we mean what form does it take? And that form is often put in words. And so when we talk about formal causes, we think about either simple things like definition or more complicated things like theories of causes. And so not only do we have the efficient causes, formal, final, and material, they exist on different levels. So you can walk around this and see that the proximate causes, the inner circle, are the things that are immediate in time and space, so or simple. So a formal cause of ADHD, a simple one would be a definition that we can agree on, like the DSM one. The efficient cause could be what got the kid into this state of running around the room and climbing the walls. The final cause, immediate final cause, is behavioral. Like, what does he get out of that? Is that escape from an aversive consequence? And what's happening in his brain at the time? But we can step back from that and ask larger questions, such as the efficient cause. What causes a kid to have ADHD in the first place, let alone get in a bout of hyperactivity? What causes the trait? The formal cause would be a complete characterization, complete theory of it. The final cause, in this case, would be an evolutionary explanation of why some humans develop ADHD. And the most extended material cause would speak to genetics and epigenetics. And the guy with all the citations was an expert geneticist, by the way. So all we have to do is separate the thing from its symptoms. You know, if you're going around holding your arm and howling with pain, I could either talk about the symptoms. Well, obviously you're having blah, blah, blah. Or I could talk about the thing, which might be a broken arm. And so is there a thing, or are there just symptoms with ADHD? And that's an interesting question. What are the symptoms? Oops, let me escape from that. What are the symptoms of it? These all cluster highly on analyses of ADHD. I want you to only read the stuff on the list, not the other things that are attempting to distract you from the list. Trouble paying attention, inattention to details. Don't pay attention to that. Easily distracted. Don't be distracted. Loses school supplies. Trouble finishing class. Ignore that. And homework. Trouble listening. Trouble following multiple adult commands. Blurts out answers. Impatience. Fidgets or squirms. Leaves. You don't ignore that. Now, please ignore that. Seems on the go, talks too much, and has difficulty playing quietly. Well, you see, you got a little bit of a hit of what an ADHD kid deals with all the time. Things that normal kids can ignore or just look at quickly and get back to work. ADHD is fascinated by these diversions from what he or she should be doing. I'll mostly say he because the majority of people with ADHD are boys. It's about 2 or 3 to 1 boys rather than girls. Why should that be? That's an interesting question. Is it really true? Or is it just that boys act out more than girls and can cause more damage, and there's an equal number? Well, it turns out more boys have it than girls. And why that's the case gets back to genetics, most likely. I had some hypotheses that we won't have time to go into why more boys than girls have these issues. I use a couple ancient metaphors. One is Aristotle's Four Causes, and the other is Plato's cave. As you remember, there's a projector here called a fire, an LCD projector. The prisoners are oftentimes faculty people. The showmen perform by throwing slides in front of the LED. Those are often grad students preparing for their defense. And they show things on the wall. And it could be data or pictures of cells or whatever. And these prisoners, who are the faculty, are trying to understand, okay, what do these things mean? Do they mean what the presenter says? So what we have on the right of your screen are all of these symptoms. These are the shadows cast on the wall. The question is, in our case now, what kind of thing, what is this ADHD thing that throws these shadows up on the wall, that casts these shadows of symptoms in front of us? Now, in terms of the most immediate layer of formal causes, diagnostic. Diagnostic is an interesting signal detection problem. Most of the things they use in the DSM are counts of the characteristics. We call that a box score. The categories of symptoms you saw, categories of syndrome, the diagnosis itself could be inattentive, could be hyperactive impulsive, could be combined type. There are no natural kinds. There are no things like broken arms in the Diagnostic and Statistical Manual. There's no thing, I mean, with the possible exception of schizophrenia, but I don't even know if that's true of schizophrenia. Nature is continuous, and so symptoms are distributed continuously. We all have a little bit of these symptoms, and the question is, how many symptoms do you need to have to be ADHD? And how do we know that's the right number? Okay. So you can think about these symptoms being distributed like normal distributions. So the people that we call normal don't have quite enough of them on the average to be diagnosed as ADHD. And those that have a few more do have ADHD. Now, I have a problem with, everybody should have a problem with this, because people that are just sub-threshold may benefit just as much from the same kinds of interventions that those that have one more syndrome have. And so in some ways, we really shouldn't be treating ADHD. We should be treating the symptoms. And we should do that equally, whether the person is past diagnostic criterion or not. I'm not going to go into this ROC curve very much at all, but another way of graphing the normal distributions is to say wherever you put your criterion, there's going to be a certain probability of being correct and a certain probability of saying the person has ADHD when in fact they're normal. And as you move the criterion on the x-axis, left and right, you're going to change those proportions. And so the question is, it's arbitrary, but where's the right place to put that criterion? There's a famous person in ADHD whose brother had it, and a brother killed himself accidentally because he was a risk taker, who feels that any symptoms at all should be treated as ADHD. And others that say, well, our treatments aren't very effective. And so what you got to do is look at the costs of misdiagnosis. So you might diagnose a kid with ADHD that doesn't pass really all the criteria for it, and he'll be labeled or she'll be labeled. and has to live with that label as being weird. And so those are some of the costs for misdiagnosis. What are the benefits? Well, and there are some drugs like Ritalin that do some good for a while. If you miss it, a false negative, these kids are risk takers. They get in trouble. And if your parents and teachers understand that the kid is ADHD, they'll recognize not to leave knives around him and so forth. So these things all need to be taken into account when you set the criterion line. Do the people that write the criteria and the diagnostic and statistical manual think this way? No. Many of them don't even know what signal detection theory is, or what an ROC curve is, or the dual roles of moving those distributions farther apart by better testing, which improves D prime or accuracy, and the other more political issue of where you set the criterion. Those are fundamental. And many people make these decisions don't understand that. We do have some good characteristics that arise from meta-analysis. Large-scale factor analyses. And there are two major factors, usually both involved, but not always. In fact, when girls have ADHD, typically they load most heavily on the attention factor, not the hyperactivity factor. And you can load on both. That's combined type, and that's the classic ADHD. So these are things that are absolutely characteristic of those with ADHD, and they're characteristic of many of us that are blessed not to have that. Bottom line here is that, how to describe it? Energetic boys mostly who don't listen to the teacher, who forget things such as what their parents told them to do and not to do. They get in trouble with their parents who think they're misbehaving, and they just forgot they weren't supposed to touch those cereal boxes in the store, and they're not acting willfully. And drugs such as methylphenidate and Ritalin, same thing, do help for a few years anyhow. They calm the individual. So, I'd like to give you a homework problem that you use this framework of the four causes to address whatever problems, experimental or clinical, you're facing. It'll be hard to get the answers, but it's worth the effort. So the efficient explanations are about efficient causes, what triggers it. The formal explanations are how do you characterize it. Functional ones say why it's there, and the material ones talk about the mechanisms for the phenomenon. The efficient causes of the syndrome of acting like ADHD. Well, I'm sorry, let's start with the ultimate ones. The causes of the syndrome of being an ADHD are prenatal. Genetics, a mother smoking during pregnancy, and even secondhand smoke from a father can do it. Being malnourished, the mother being under traumatic stress as in war or migration, anything that puts the mother's body in stress can take a fetus that has the genes for ADHD and turn them on. That can also happen with birth trauma, being born prematurely, having head injuries for a young child. Persistent issues are family difficulties, stress in the house, or parental pathologies. If it starts getting triggered, those will really keep it going. And others are parents that are not responsive. They ignore the kids, or they're very critical of the kids. The kids are bored out of their mind or overstimulated. The parents are abusive, or there's abusive marital relationships. All of those things take a very weak genetic signature and trigger it into being active. The proximate causes of ADHD behavior symptoms are things such as monotony. That's number one. Okay. So behavior modification, how does that come into play? The most meta-analysis of behavioral interventions showed that the use of 4 self-regulation interventions really help. Self-monitoring plus reinforcement's even better. Self-management and self-reinforcement, all 4 of those in different experiments really help moderate the symptoms. Nothing changes the kid from being an ADHDer, except some of them grow out of it. Combined effect sizes for these 4 treatments were greater than 1, which is darn good effect size for on-task behavior, inappropriate behavior, academic accuracy. So these interventions are effective. And I want to tell you about an opportunity. I don't know how accessible it is, especially in this pandemic time, but one of the leaders, behavioral leaders in the field, is Dr. William Pelham in Florida. And he runs a summer program where parents bring their kids with ADHD or conduct disorder often grows out of ADHD. If you're not real careful in handling a kid with ADHD, the kid gets tired being blamed for things he can't control and starts generating a real attitude. And it's actually a DSM category called conduct disorder, which arises from other causes too. But kids with ADHD are in risk of developing conduct disorder, which means being a real pain in the ass to those around them and doing things that are often illegal and certainly anti-civil. Oppositional defiant disorder is the same thing. No, I'm not going to take the garbage out. Who the heck says I have to take the garbage out? I'm not going to take the garbage out. And so on. The program addresses all of these, and it's looking for, his technique is good behavior control, stimulus control, self-management techniques, and low doses of Ritalin, just to keep the lid on while they're learning these things. They're looking for 100 students to help out running the summer camp this summer. So Google Pelham, Florida. This is the link that you should write down, and I'll put it in the chat later if you want, to inquire about whether folks from other countries can come and get this experience. Be good for everyone. Formal causes. Well, we talked about the descriptions and definitions. The ultimate formal causes are good theories and models. There's a lot of theories and models around. I don't know how good they are. I don't think anybody thinks they're good. Barkley, one of the leaders in the field, prior generation, said, well, the cause of it is inhibitory failure. Well, kids do have trouble with inhibition, but that's not clear to me that's the cause of everything. Sunukabart, delay aversion. Yeah, the data for that are pretty meager. Joe Sargent, executive. By the way, some of these people were in that photo I showed you. All of them visited this institute during my time there. Joe Sargent, who sort of ran ADHD in Europe for a generation, believed it was executive function and what he called cognitive energetics. Terje Sagwalden, his student and my dear friend Johansson and associates, argued that it was a short delay of reinforcement gradient. There's some evidence for that. Swanson and Levy said it was timing dysfunction. I don't know about that. So these are the various theories that have been floating around. What's it for? What's it for? Why is ADHD? By the way, it took me 6-7 months to start getting this stuff figured out. It was such a fog for me. The final causes, the proximate ADHD behaviors. The kids are trying to escape or avoid painful concentration. You know, you try to do something tedious, longer than you can maintain concentration. It's really aversive. They're giving themselves time out by doing other things. What that means is that if you're going to be teaching kids with ADHD, you give them lots of breaks or change the particular tasks they're working on. You go from English to mathematics to geography every 10 or 15 minutes at least. The ultimate final causes. It shouldn't be in the gene pool, it seems. There's ADHDers are overrepresented in prisons. They're overrepresented in emergency rooms. They're overrepresented in drug rehabs. It's not the kind of thing that is going to make you have lots of healthy kids raised to maturity. Yet about 8% of boys are diagnosed with it. So what keeps it in the gene pool? Smaller percentages than 8% against a trait will, especially for young people, not for old people, but for young people, will take it out of the gene pool within a dozen generations. So what keeps it there? How is it functional? Here are some people that either at the time or retrospectively were diagnosed with ADHD. Now, a lot of these historical figures like Alexander Graham Bell, you're reading the tea leaves of their lives and their activities. Thomas Edison, there are enough contemporary accounts, there's no question in my mind that he had it. I don't know how many of these others really did have ADHD, but they all exhibited many of the symptoms of ADHD. And remember, this is a continuum. I wish I had more symptoms of ADHD. I wish I had the energy that comes with it, the drive that comes with it, the enthusiasm, all of these things that can come with it. I don't want the whole 9 yards of it, though. So, look at Agatha Christie. How many great mystery novels has she written? Wow. So, Robert Downey has had his run-in with drugs. So there are positive sides to this. It's not the curse of Satan. There are positive sides as well as risks. It's a high risk, high gain, high risk strategy. Let me go on with some more of this. We've talked about those aspects. What I'm going to, oh, by the way, I'm not sure I'm going to come to this later because my slides are jumbled, but the material causes. The ultimate material cause is highly heritable, very high heritability. If a father has ADHD, pretty decent chance that his son will have ADHD, especially if exposed to stress when young or in utero. The material myelination, there's a sheath of sort of fatty stuff that goes over the neurons, and they keep the charge doing what it needs to without using up too much energy. And neurons get myelinated, not immediately, but over the first months and years. And when those get delayed, as it does with ADHD kids, it takes much more energy for their neurons to function. The proximate material cause, many people think it's a dopamine dysfunction because methylphenidate is a dopamine uptake inhibitor, which means it puts more dopamine in the system. And so they figured, well, kids don't have enough dopamine. Well, at that point of fact, nobody knows that that's the case. And in fact, there are other things that work with ADHD that have nothing to do with dopamine. Our hypothesis, as you'll see, is that it's an energetic dysfunction. So I want to tell you about a simple developmental model, a compartmental model of energetic supply and demand, and develop it from a simple model of response times. Extend it to attentional fugues. That's when the kid says, oh, what was that, a squirrel? And goes off, does something else. and show that it works. So here are some more of my colleagues. He saw the woman in the middle at the table at Oslo. We were 2/3 of the way through our time in Oslo, and we'd done good stuff. It was very traditional, nothing breakthrough. And we got frustrated, and we went out for a walk in the woods just behind the Institute. And I had other companions as well, but these three were quite stimulating. And we decided to go for a walk together and talk about what the hell are we doing here? You know, what is ADHD? And all of these women are phenomenally productive researchers, although some have retired at this point. The one with the glasses, Viv Russell, is an expert brain scientist, neurophysiologist. And she had some ideas that developed into our theory. This is how the brain gets energy, okay? Let me catch up with my notes here. Okay, the neurons on the left, the top left one is sending a signal to the bottom left one. And it does that by releasing glutamate, and it gets picked up by glutamate receptors. While it's doing that, some of the glutamate goes to other neurons that it gets picked up at, and these are called noradrenergic varicosities, and they release these little red dots that are norepinephrine. And these go to the star-shaped thing in the middle, in blue-gray, and that's the astrocyte. There are as many astrocytes in the brain as there are neurons. Astrocytes perform many functions. One of the main functions is sending lactate to the neuron. You can see that with the blue arrows at the top. So when the glial cell gets evidence that cell is firing, it knows, so to speak, that it's going to need more energy, which it gets from lactate. Without the astrocyte giving it extra energy, the neuron can only fire for 5 or 10 seconds without slowing down tremendously. And so this thing's got to be pretty fast. The astrocyte gets glucose from the blood vessels on the pink thing, converts it into either lactate directly, or it stores it as a more readily available form of energy called glycogen, which it can then break down to lactate. So the glial cell, the astrocyte, is the go-between between the blood vessels. It absorbs all of this good glucose, converts it, stores it, releases it as needed. It takes a long while to build up the glycogen, and a lot of that work is done at night, and that's when you're sleeping. That's a really important reason for kids, all people, to sleep, is to recharge their astrocytes, give them fuel back. Maybe that's the main reason we sleep, to prime the pump for the next day's thinking. So our hypothesis is going to be that something gets stuck in this network so that you can only pay attention for a while. And then your ability to fire those neurons just poops out until they get resupplied, and they're getting resupplied at a lower rate. Now, if you look at the energetic metabolism in the brain, the panel you see here is one of about 6 or 7 or 8 pathways. It's always been important that the brain gets energy. The brain is not parsimonious. It develops one way. This works pretty good. It develops another. It doesn't necessarily throw out the first way. It piles one good thing on top of the other unless they start tripping on themselves. And so it's very complicated. If this is our theory, how do we go about? I tried fitting a model like this to some data, and there were just too many degrees of freedom in the model and too many assumptions. So Bohr's theory, Niels Bohr, the famed quantum mechanical guy of 100 years ago, Um, he thought complementarity wasn't just talking about quantum mechanics. He thought it was a model for the world. And he said that the more precise our description is, as in these very precise models, the less comprehensible it is. You've all seen that. Keep it simple, stupid, but no simpler than necessary to get the job done. The Tai Chi symbol, yin yang symbol, was on his coat of arms. And that was the balance between complexity and simplicity. So I developed, instead of this complicated model on the left, the simple 2-cell model on the right, to try and, as stimulation frequency comes in from the neuron, it starts releasing transmitters and asking for energy from the glial cell, and the glial cell tries to replete it. And I actually use that very simple, those of you that don't do math, it doesn't look simple, but those of you that do math, this is a trivial differential equation model. And it fit the data for the change in lactate from Caesar and Associates as the cell is firing and then as it's depleting. So that basic model fit the cells okay, because there are thousands of cells involved in any computation. And so all of this works out en masse. I used to have a movie going with that, but it's not worth spending time on. So what I showed you before was simple stuff. This is mass action. What happens when you have thousands of neurons firing like that? What we expect to have happen is the distribution of times that cross the finishing line will be like a skewed normal distribution, sort of like an X-Gauss, but it's got its own form, and it's called a Wald distribution, W-A-L-D distribution. This is used in many of the modern cognitive psychology models of drift diffusion models of decision making that combine both signal detection theory and latency, how long it takes to make a response. So this is going to be my model for untangling the data and translating it into energy, criteria, and variability. These fall right out of this model. So the model is tied to mass action of neurons. So here, for instance, are some classic data, I forgot whom I got them from, that, see if I can find it in my notes. Okay. Oh, by the way, this model actually originated in Einstein's work on Brownian motion. Kern and Berken looked at controls, ADHD hyperactive, ADHD inattentive, and ADHD combined type, and looked at response times in a standard cognitive task. And so I was able to use this model to translate these distributions into these two indices that are so important. One of them is energy, which governs the speed at which these neurons are able to cross the threshold for a decision. And the threshold is C, the criterion. So two key parameters and a third derived one. The energy, and so if you look down in the graph, on the x-axis we have the control group, the inattentive, the combined type, and the hyperactive impulsive. The criterion, it's arbitrary order on the x-axis, but the criterion, that is how quickly you'll make a decision whether you've got enough data or not. It's a speed accuracy trade-off. And the further to the right you go on those syndromes rather, the lower your criterion. You're going to jump the gun more often when you're hyperactive impulsive than when you're control type. And the energy available is below control for all these groups. Remember, I'm interpreting energy as the speed of neuron firing ensemble. And it's a pretty reasonable interpretation. So all of the ADHers don't have as much energy, especially the combined type, as the controls do. And we see the same story play out. If you look at behavior over time, the ADHers I always do as triangles for the A, and the circles as control for the O. And you'll see that the ADHers take longer on some basic task, and it increases with time on task more than it does for controls. Pardon me. The standard deviations, which are derivable from the model, pretty straightforward, go up. So if you look at the things on the data in the bottom on 3 different studies, you see that I forgot what large means. If you look at, it's not worth talking about all of those little numbers there. They tell a consistent story. Means are for ADHers and response times are always longer, and most importantly, the variability, the standard deviation, is larger, and it increases over time. It increases with the So here's a model I'm not going to tell you too much about, and I'll tell you why I'm not going to tell you too much about it with a question in a minute. But this is a Markov model that I developed. A person is either in the attentive state or the inattentive state. If they're in the attentive state, as soon as the target comes on, they'll respond to it with the characteristics on this rectangle down there. The mean will be the criterion divided by the energy, mean response time, and the variability, the variance, will be the criterion over the energy cubed. But if they're in the inattentive state, they have to snap back to intention, and that adds this other process called tau to the mean and tau squared to the variability. So we get these parameters out that with an adequate database, we can map all of these, the probability of pay attention, the means and the variances, to behavior. Now, I almost apologize for doing this because I remember a colleague once telling me why mathematics was like sex. Now, I want you all to think about that question. Why is mathematics like sex? And at the end of my lecture, if anybody wants to know what he told me the answer was, it's relevant to this slide, okay? But you come up with your own answers. I think you'll have better ones, even. So I use these, and I can get leverage on more complex data patterns and see if they're consistent with models such as these. And this is data from Leth Stenson a couple decades ago, where you had performance on continuous tasks where you have an inter-stimulus interval, how long you have to wait to get the second stimulus to complete the task. And you see the bottom panels on the ADH boys are much flatter and spread out. And the top panels, there's much less variability in response times, key signature between ADHD and these kids. And the normal are generally faster. I mean, they traditionally developed rather than ADHD. I don't want to say normal, are faster. And from this, we can get measures of the energy. Control has twice as much as ADHD kids. The criterion, the control waits doesn't wait longer, but it's got a higher, it needs more data. It gets getting it twice as fast. And it's got a slightly longer criteria, meaning it's going to be more accurate, make fewer energies. And the probability of an attentional lapse is 1/3 for controls that it is for ADHers. But if they're not attending, how long the target takes to get them back is about the same. Pardon me a second. I stifled a sneeze. So in many of these experiments, you have to keep going again and again and again. And that's what pulls apart kids on memory tests, such as the one by Rapport. More data confirms the model. I won't linger here. More data. So what's nice is that you can get estimates. You don't need the whole distribution. You can get them estimated from response times in terms of the basic statistics. Energy is the square root of the mean over the standard deviation, and the criterion is the 3/2 power of the mean over the standard deviation. And that codes these descriptive statistics into theoretical ones that are theoretically meaningful. And then there was this big study, and the model fit the data very well. So if the theory is correct, C should be related to impulsiveness, because that means it's a lower criteria for responding. These are data from Tannick up there. Was the woman in the middle you saw with the gray hair. She was on the team, and Gordon Logan is a well-known cognitive psychologist. She was on the team that independently measured impulsivity. And I got her response time data and converted it into C, the criterion. And so you see on the x-axis, as independently measured impulsivity increases, the criterion as measured from the response time decreases. So, that looks pretty good too. Okay, the more methylphenidate you get, the more energy you have is measured from response times, and the higher your criterion can go. This is data from Anouk Shiris et al. So NEMA, my neuroenergetics model of attention, does not predict hyperactivity particularly. It's consistent with it, okay? It's consistent with it. The hyperactivity itself might be a way of jacking up the energy in the brain. The tapping of the feet and the scrambling around is another way to energize the brain. And so it might be actually not a symptom of ADHD, but rather a coping mechanism for ADHD. It doesn't predict delay aversion. And sometimes you get delay aversion and sometimes you don't. It doesn't predict a lack of motivation, because I don't think these kids lack motivation. Does not predict a frequency reinforcement effect, which is said to improve behavior. It does improve behavior, but it does it for normals also. Big surprise, eh? But frequency of stimulation will help to recapture attention. It does not predict a magnitude of reinforcement effect, that is, bigger rewards are differentially predicted to be good for kids with ADHD. I think those data are also questionable anyhow. The model does not predict that dopamine will be especially good. It predicts that dopamine will help because dopamine also causes release of lactate from astrocytes. So it does get in there and shout to astrocytes. But it also says that any drugs that directly or indirectly stimulate astrocytes will do the job. Amphetamines will do it, atomoxetine will do it, MAO inhibitors will do it, and tricyclic antidepressants will do it because all of those stimulate the astrocytes, and no other theories handles those. It doesn't explain why alpha adrenergic agonists seem to work, because they don't particularly stimulate the astrocyte. So theories. So some of the recent anymore, but some of the more recent work on this were these two articles. Viv Russell is the brain scientist that was at the core of all of this. I did all the modeling and most of the theorizing. And Joe Sargent really just made everything happen running the ADHD. So I'm going to sort of wrap things up now and leave time for some questions. Let me get my notes here up to date. This model has been tested independently by 2 or 3 other people that have no relationship to me, and they find that the predictions of the model generally are true. Sometimes the criterion doesn't change in ways we might expect, but it's always the case that the index for energy varies between normally developing and ADHD kids the way it's predicted. And so this is how I bridge between experimental psychology, simplest possible compartment model of material causes, energetic processes, and simplest model of behavioral processes. And then they luckily meet halfway and make sense of one another. So to review, diagnosis of ADHD is really, it's voodoo. It's not a thing called ADHD. There's no gold standard. There are cost-benefit issues of where to say ADHD. And it's comorbid with many other dysfunctions. It's rare to find a kid with just ADHD. And it's rare to find many kids with other certifiable DSM conditions that don't have something like ADHD. And certainly subclinical ADHD. So it's a constellation of symptoms. I think many of them caused by energetic insufficiency. The efficient cause by early stress on susceptible genotypes. The genotypes have been found. That guy with the high citation record found a number of them. But together, they only account for less than 1% of the variance in the data. And that's often how it is with genetic, GWAS they call it, genetic-wide screening. There are no adequate theories. You know, it's a heterogeneous issue. And I think the neuroenergetic theory is, my biased opinion, as good a theory as we're going to get. Final cause, why does it exist? Well, let's suppose that you're in utero or a young child and the world really sucks, like it does right now with the pandemic, or your father is brutal to you, on and on. Do you want to stick around, you know, and inherit the farm and do the same old stuff, or you want to get the heck out of there? I think when young people are subjected to stress that the parents can't protect them from, or maybe are the cause of the stress, it makes a lot of sense to climb over the fence, go to the next town or the next country, get the heck out of there. I wouldn't be surprised if many of the Vikings had ADHD. Many of the explorers had ADHD. They just always want to climb that tree, climb over that fence and get out of there. We saw there are early myelination problems, that certain drugs, amphetamines and dopamine uptake inhibitors, multiple effects, and one of them, and we think the most important, they stimulate the astrocytes. So then this is the energetic hypothesis. Makes ongoing attentional demands difficult, predicts poor performance at low events rate. More data needed to test it, but that's happening now by young colleagues in other institutions, and the data is supportive. There shouldn't be a stigma about ADHD. Dennis them and his kids. They can be the most productive people in our society. Our challenge is to find ways to get them past all the threats that lie along their path to self-regulation and excellence, to help them stay away from drugs and stay out of prison and stop jumping off of roofs. This is Terry Sagwalden. He's the one that organized the ADHD conference and session and year in Oslo. Terry was a student and friend of Charlie Catania. Many of you know Charles A.C. Catania. He's one of the leaders in the field. Terry Sagwalden did a postdoc with him and came back on sabbatical many times and worked with Catania. He had boundless energy, and he convinced the Oslo Institute for Advanced Study to do something never had to get done before. They'd normally just bring in various people. He said, no, we need to select the best people we could get to focus on a single issue that never been done before at the Institute. And he also convinced them that they needed to pay us to get away from this heaven of thought, to go out to Svalbard, an island up near the North Pole, just to get together, but also so we could see polar bears. Terrier clearly had ADHD, and he was one of the most productive people in this business. And he died too young of a heart attack, to my great grief for losing a friend and a stimulating colleague. So that's my story, folks. And I'm going to stop talking now so you can ask me any questions that you would like to. Let me stop presenting to everyone so you can speak. Very good. I should be able to hear you now. Why don't you test that and see if it's true?
Thank you so much, Professor Peter Killeen. It was amazing. So let's see if we have some questions in the website. Lauren, do we have questions? We're waiting.
Well, I have a question. Remember, I asked you a question. Well, I asked you two things. Try to use the 4 causes model for your projects. And you can find, I've written it up a half dozen times on ResearchGate. You can find my papers on it. But I also asked you another question, or I posed one that a colleague posed to me. Why is mathematics like sex? Remember that? What did you come up with? What were your answers to that?
They are cute. Okay. You, Lauren.
Yeah. That's perfect. It took me a long while, both to get math and to get sex. So you right on. Yeah. And sometimes you're lucky with both math and sex and can have a marvelous, okay? But answers to that question before I tell you what my friend said. Good. Thank you. Good seeing you. I didn't say that. That's a wonderful additional insight, Lauren, that diversity of some people that like to sit in one place all day long on their butts doing work is helpful to the community, and people that can't stand 5 minutes of that can be helpful to the community, and only with a respect for everyone in it can we have an evolutionary stable strategy as a group. Well said. Yeah. Thank you. Okay, I will tell you some of the answers. I've asked this question before, and sometimes you get embarrassing answers, and sometimes just funny. Like one person said, "Well, 3 is greater than 2," and on and on. But Friedman, who asked me this question, told me his answer. He said, "Peter, mathematics is like sex because they're both best if they're not done in public." Okay? And so that's why he was telling me not to get too complicated mathematically in front of an audience. I didn't tell him that some people think sex in public is good, but that's a minority, I think.
Yeah, we think. I don't know if we have some questions here in the room. Some of my students. ¿Tienen alguna pregunta, chicos? Even in Spanish, if you want. O sea, si en español y quieren que la traduzca en inglés. I think they are very shy, I guess.
Yes. That's okay.
Yes, I have some reflections about your presentation. About I was thinking about comorbidity among substance use disorders and ADHD or control impulse disorders in general, thinking about how this neuroenergetics theory or this metabolism in the neurons glia could be affected when we have, toxic, drugs in the brain. And for example, these cases that we have seen, as you see, I don't know, these persons who are practicing sports with contusions, several contusions,
Yes.
and they use drugs, and they have this terrible parenting in their history. Yes. So, it's accumulation of many things that even, the human being has to adapt to all these things. Mm-hmm. And how the metabolism in the brain modifies to way to adapt to all these contexts. I was thinking in that. Have you ever considered the effects of drugs in your model?
The brain doesn't. All ideas of the brain was this part of the brain does something, this part of the brain does something else. Generally, that's not the case. Most processing in the brain uses most of the brain. Okay, even when they do these fMRI scans, they have to set a threshold because the whole brain is active during any task, and they have to say, well, what's the most active part? And in fact, some of that activity could be coming from the signal, the bold signal, by the way, that blood oxygenation level detector speaks to fMRIs work because they detect extra blood going to regions to feed the astrocytes, to feed the neurons. So that's where the whole thing comes from. Well, the whole thing is spread out. And so depending on what the kind of trauma is, different parts of the brain will be impacted differentially, and they will feed into this network that the brain needs for almost any task. It needs large parts of the brain. And so the differences from concussions, from drug use, and on, all play into this complicated interaction of different parts of the brain. So everyone's a little different from the next one. But they'll often, they often may, in fact, involve oxygenation issues and neuroenergetic issues. But how they manifest depends on what part of the brain is hit the hardest with these issues.
Yeah, of course. I guess we have another question. Alejandro Macias, he said, to which degree material causes, such as dopamine or energy, are the causes of ADHD and not the effect of other external cause? External cause?
Well, yeah, external causes, I guess. That's an interesting question. I'm not quite sure how to answer it. We know that hyperactivity itself might, instead of being a symptom of ADHD, a coping mechanism to try to get parts of the brain pumping again, okay? Running around, getting a diversity of stimulation, which is part of ADHD, but also pumping up adrenaline in the brain, because when you do these things, adrenaline goes up, and when adrenaline goes up, that releases more lactate from the brain. So we know that could go either way. You know, it could be either caused by ADHD or it could be a response, a healthy response to ADHD. Now, these brain energetic things that I'm hypothesizing is part of the material cause, could those be not really part of the material cause? It's possible. I don't think there's any other good theory about how the brain is changed to explain what's going on here. There's a lot of things that are consistent with it. Observations about data, and I wouldn't know what to say or do if you said, well, we proved that neuroenergetic model really is not part of the material causes. I'd say, well, okay, I'm wrong. I don't know what part of the material causes are then. You know, there will be material causes to anything. There will be changes in the physiology, and so could the neuroenergetics be a byproduct of these other things? I don't know, maybe, but I don't know how that would work. This is, you know, after spending 10, 15 years doing this, I'm not doing it anymore. It's time for fresh minds. And so the person that asked that question, it's a good question. You know, doubt everything as a scientist. Good luck on finding a replacement. The changes and advances are going to come from.
Yeah.
But I wouldn't know how to do anything with that suggestion.
Yeah. I think it's part of genetics. Yeah, I don't know. I'm thinking right now when your parents had these problems with ADHD, and you know, and they are parents now, and you are the baby of that parents. That's the important thing about genetics. I mean, about all that information that our parents have in that in their context, and it's part of that, and in all that learning about the parenting too. I mean, how they teach us many things during childhood, and so it's
that's very well said, because the heritability, Deanna, is very high, but that doesn't just mean the genetics. Oftentimes, young people will raise their children the way they were raised. And if I was raised by an abusive father, which could be a cause of ADHD, I'm likely to abuse my child, unless maybe I marry a wonderful woman who shows me the error of my ways. And so heritability doesn't just mean genetics. It does mean genetics, but not just that. The genetic links we found are so weak, but the heritability is high. Part of it is genetic susceptibility, and part of it is being stuck in a ghetto. If your folks grow up in a marginalized community, you're likely to grow up there, and your kids are likely to grow up there. And that will make it heritable. You know, if parents or kids have enough to eat, that's going to be a trigger for it. If you're a Black person in America, you are oppressed. Not every person, not every Black person, but they live in a climate of oppression. And so you'd expect ADHD to be higher in people of color. It tends to be.
Yeah. Thank you so much for all these reflections, Professor Killeen. We are so happy. We learn a lot.
That's my pleasure. I look forward to enjoying the forthcoming talks also. Congratulations on putting together a great conference.
Oh, thank you so much. Okay, then I'm going to talk about in Spanish. Agradezco mucho al profesor Peter Killeen por darnos esta gran conferencia, por darnos la oportunidad de reflexionar sobre este tema y evaluar justamente factores genéticos, de prácticas de crianza, estructuras cognitivas referentes neurobiológicos de estas condiciones, bueno, de esta condición que propiamente hablamos que fue el trastorno por déficit de atención. Y pues bueno, para algunas preguntas que tengan, si son tímidos pueden dejarlas, en su momento veremos cómo contestarlas. Y pues bueno, continuamos con la siguiente conferencia. Ok, vamos a ir un backstage y vamos para presentar a la doctora Ida y iniciar. Ok.
Well, again, thanks everyone for tuning in today. I hope you enjoyed Dr. Peter Kilin's talk. Peter, thank you for your amazing presentation. Before starting our next talk, I would like to give you a couple of announcements. We are transmitting all the talks live on YouTube, Facebook Live, and the GECC platform. So feel free to join in those channels, whatever it's best for you. If you have any questions, you can contact us via Twitter. Our Twitter is @_GECYC. You can also put all your questions on the chat at the GECC platform, the YouTube channel, or email directly any of the organizers, Lauren, Diana, or myself. Lastly, I will post a link to a Google form in the GECC platform, the YouTube channel, and also the Twitter. Please fill out the Google form, which will be important to obtain the certificate of attendance. Continuing with our program, it is my turn to introduce not only a lab partner and a colleague, but also one of my best friends. For me, it's a pleasure to welcome PhD candidate Aida Longan. For those who are unfamiliar with Aida's career, she's graduated from the psychology program at the University of Barcelona in Spain. She studied a master's in ethology from the University of Córdoba in Spain too, a second master's in behavioral sciences from the University of Guadalajara in Mexico. Of course, during her professional career, Aida has carried out a multiple internship at professional stays in various institutions, among which stands out the Primate Rescue Center at the Mona Foundation in Girona, the Ethology and Cognition Laboratory of the University of Sao Paulo in Brazil, and the Theology Laboratory of the University of Barcelona in Spain. Currently, she's a doctoral student in Dr. Jonathan Buritica's Cognition and Comparative Learning Lab at the Center for Studies and Research in Behavior for the University of Guadalajara in Mexico. And Aida is going to talk about the mechanisms of innovation in rats today. Just as a reminder, Aida, you have 45 minutes to present, and after that, we will have 10 minutes window to ask you some questions. Now, Aida, I will do all this presentation in Spanish, so wait me one second, okay? De nuevo, gracias a todos por conectarse el día de hoy. Espero que hayan disfrutado la charla del doctor Peter Kilin. Peter, muchas gracias por tu presentación. Antes de comenzar la próxima charla, me gustaría dar un par de anuncios. En principio, estamos transmitiendo todas las charlas en vivo en YouTube, en Facebook Live, en la plataforma del GECC. Si tienes dudas, contáctanos vía Twitter. El Twitter del GECC es @GECYC. También pueden mandar todas sus preguntas en la plataforma del GECC, en el canal de YouTube, o bien envíen un correo directamente a los organizadores, a Lauren, a Diana o a mí mismo. Y por último, voy a estar publicando un formulario de Google en el chat de la plataforma del GECC, en el canal de YouTube y en Twitter. Por favor, les pido que a todos los asistentes a este congreso llenen ese formulario de Google, porque será importante para obtener el certificado de asistencia. Continuando con nuestro programa, es mi turno de presentar no solo a una compañera de laboratorio y colega, sino también una de mis mejores amigas. Para mí es un placer enorme darle la bienvenida a la doctorante Aida Longan. Para aquellos que no estén familiarizados con el trabajo de Aida o con su carrera, ella es licenciada en Psicología por la Universidad de Barcelona en España, estudió una maestría en Etología por la Universidad de Córdoba también en España, tiene una segunda maestría en Ciencias del Comportamiento por la Universidad de Guadalajara en México, y bueno, ella ha realizado múltiples prácticas y estancias profesionales, entre las que se incluyen el Centro de Rescate Primario de la Fundación Mona en Girona, el Laboratorio de Etología y Cognición de la Universidad de Sao Paulo en Brasil y el Laboratorio de Etología de la Universidad de Barcelona en España. Actualmente, ella es estudiante o es doctorante del Laboratorio de Cognición y Aprendizaje Comparado, el doctor Jonathan Buritica, en el Centro de Estudios e Investigaciones en Comportamiento de la Universidad de Guadalajara en México. Aida hoy nos va a platicar un poco acerca de los mecanismos de innovación en ratas. Entonces, Aida, como te comentaba, tienes 45 minutos para tu presentación, luego vamos a tener una ventana de 10 minutos para preguntas. Así que, Aida, cuando estés listo, el micrófono es tuyo. Mucha suerte y espero que todos disfruten.
Muchas gracias, Alex. Muchas gracias por la presentación. Voy a compartir mi pantalla. se lo están viendo bien, ¿verdad?
Sí, perfecto.
Vale. Bueno, pues como dijo Alex, hoy les voy a hablar sobre un tema que llevo estudiando desde el inicio de mi maestría hasta ahora, que ya estoy casi en el final de mi doctorado. Son los mecanismos promotores de innovación en ratas. Y pues lleva un largo camino de investigación, pero hasta ahora les voy a contar más o menos toda la revisión bibliográfica que he estado haciendo, lo más relevante, y cuál ha sido mi estudio y los principales resultados. En general, en la literatura no hay una única definición de innovación. Dependiendo del autor, se pueden encontrar condiciones diferentes que van a variar en su definición. Sin embargo, una de las definiciones más citadas y aceptadas es la propuesta por Reder y Lalan en 2003, en la que se concibió la innovación tanto como un producto como un proceso. ¿Esto qué significa? Que la innovación no sé por qué se pasó solo. La innovación no solo es un patrón de conducta novedoso, como puede ser una solución a un problema específico, sino que también se puede concebir como un proceso de un modo novedoso de afrontar el medio ambiente. Hay muchos ejemplos en el reino animal, por ejemplo, en las fotografías que vemos en la derecha, arriba, en la superior, es un herrerillo común que en 1920 se empezó a ver cómo habría botellas de leche en Gran Bretaña, en una pequeña región de Gran Bretaña. Pero ya para 1950, esta técnica de apertura para alimentarse se propagó a través de toda la población de Gran Bretaña y prácticamente todos los herrerillos de Gran Bretaña sabían abrir botellas de leche. Otro ejemplo de un proceso de innovación es el del lavado de patatas por los macacos japoneses, que lo vemos en la imagen inferior, en este de aquí. Se vio cómo se empezó culturalmente a transmitir este lavado y en una región cada vez se fue propagando más esta técnica. Otro ejemplo de innovación, pero como producto, sería este elefante en el que tiene que conseguir alimento que está en lo alto. Y para ello se buscó un objeto como un taburete o un cubo en el que podía poner sus patas para aumentar su altura y llegar al alimento. Y los cuervos pues son grandes conocidos por sus habilidades en el uso de herramientas. También puede considerarse un método de innovación cuando utilizan nuevas herramientas o incluso utilizan herramientas para obtener otras herramientas que les van a proporcionar el alimento, ¿no? Se ha visto en cuervos de Nueva Caledonia, en Nueva Zelanda, que incluso pueden secuenciar 4 conductas para llegar a un mismo objetivo. Esos son los ejemplos principales que se consideran parte de la definición de innovación: la explotación de nuevas fuentes de alimento, desarrollo de nuevos métodos de procesamiento de alimento o el uso de nuevas herramientas para conseguir alimento. Por tanto, la innovación juega un papel muy importante en el fitness y la supervivencia de estos animales, ¿no? Por lo que en relación con la evolución y la ecología también juega un papel muy importante. Por ejemplo, han habido estudios que han relacionado el tamaño cerebral y en particular algunas áreas cerebrales como las prefrontales en primates o las áreas equivalentes en aves, en los que cuanto más grandes son esas áreas se correlacionan con una mayor probabilidad de innovación. También animales que viven en condiciones ambientales cambiantes, que tienen que estar adaptándose a nuevos ambientes continuamente o tienen que prever que van a faltar recursos en otra época del año y necesitan abastecerse antes, pueden generar más conductas innovadoras para esto. A pesar de toda esta importancia de la innovación para la supervivencia y en general a todos los niveles ontogenéticos y filogenéticos, los procesos y mecanismos que subyacen a la innovación y sus consecuencias todavía no están claras. Falta aún mucha investigación y pues ese es uno de los objetivos de mi tesis de doctorado, dar más luz en este tema. Ya de la revisión bibliográfica que hice sobre innovación, dos de las principales explicaciones causales son opuestas en su base. Las explicaciones causales sobre la emergencia de innovación puede verse más como una reestructuración del campo visual, como algo que surge de forma repentina y que no necesita una planificación, como una idea que se te ocurre en la mente que te viene de la nada, como sería, por ejemplo, el cubo de Necker, que lo podríamos ver como la cara de esta manera, o de forma espontánea podríamos ver que la cara está de este lado. ¿Va? O se explicaría su emergencia más bien como un entendimiento de las relaciones causales, que es una de las explicaciones que más ha sido aceptada y más ha sido estudiada, en el que el procedimiento sería incremental a partir del conocimiento previo de los elementos más relevantes del problema. Como, por ejemplo, resolver un problema como el de las torres de Hanoi. No sé si lo conocen, es muy famoso en psicología, en el que hay como inicio tres discos y tú tienes un final, un objetivo final en el problema. Los necesitas poner de esta manera, pero necesitas saber cuáles son los pasos para llegar del inicio al objetivo, con unas normas. Nunca puedes poner un disco de un diámetro mayor sobre uno menor. Entonces, la resolución va a venir a través de la planificación de cómo vas a ir poniendo los discos para poder llegar a esa solución. ¿Va? Entonces, lo que dice esta explicación causal es que la innovación sería un proceso más similar a un entendimiento de relaciones causales que una reestructuración del campo visual. La innovación se estudia en su gran mayoría a través de la presentación de tareas-problema a los animales, ya sea en cautiverio como en libertad. Los encuentros repentinos de innovación en libertad son extremadamente raros y sería muy difícil estudiarla de esta manera, por lo que las metodologías suelen consistir en la presentación de problemas que posiblemente nunca hayan experimentado previamente estos animales a lo largo de su vida. Esa sería la metodología de la primera exposición, que sería esta de aquí, en la que la resolución del problema se explicaría en base a la filogenia y la ecología, como por ejemplo es la tarea de stream pooling. Es una tarea en la que, por ejemplo, en aves es de forma vertical, pero también puede ser presentada de forma horizontal. Y se ha hecho mucho, por ejemplo, en cuervos, en los que tienen diferentes disposiciones y tienen que elegir entre un alimento, uno que es comestible y otro que no, o uno que es más grande, otro que es más pequeño, una disposición paralela, una disposición cruzada, y van viendo cómo hay un entendimiento de las relaciones causales entre el inicio y el objetivo, ¿no? En cambio, otra perspectiva sería la de metodología de estudio de entrenamiento previo, en la que los conocimientos y la experiencia previa sería lo que más resaltaría, serían las explicaciones causales de la resolución del problema. Por ejemplo, la tarea de desplazamiento de caja de Epstein, en los que se entrena a palomas a subirse a un cubo para picar una banana, como sería el ejemplo del elefante que hemos visto en la imagen. En este caso, la forma de investigar la innovación sería entrenando a la paloma a conductas relacionadas con problema o sin relación con el problema, y de las relacionadas con el problema, hasta qué punto necesitan ser entrenadas para poder resolverlo. Por ejemplo, en el caso del cubo, la paloma necesita empujar el cubo hacia una dirección concreta. Si las palomas no eran entrenadas a empujar el cubo hacia una dirección, después cuando se ponía la banana y el cubo juntos en la tarea problema, no eran capaces de resolverlo. Este es un dibujo del recorrido que hacían con el cubo las palomas. En cambio, si a las palomas las entrenabas a empujar el cubo y a subirse en él y picar, cuando se les ponían los dos elementos, resolvían la tarea de forma espontánea, continua y directa. Entonces, el énfasis que se le da desde esta perspectiva sería más bien de la experiencia previa, a diferencia de la filogenia o la ecología, ¿no? Un ejemplo de la tarea de stream pooling es un estudio que hicimos en colaboración con Alejandro en el Parque Ecológico Zacango con la tarea de stream pooling en diferentes mamíferos. Entonces, a ver. Este, por ejemplo, era en leones blancos, en osos negros, en chimpancés hicimos varias disposiciones. Esta era la paralela. Este es un oso de antifaz. Este es un orangután que no estaba tan motivado por participar en la tarea, pero también la resolvió en forma paralela, en el que uno hay alimento y en el otro no. Y en este es en chimpancés también, la cruzada, la disposición cruzada. Y también lo pueden resolver. También se intentó con elefantes y con cuervos. Y bueno, las hipótesis explicativas sobre innovación que han sido más citadas y las que hasta ahora se han propuesto son dos que son mayormente opuestas también entre sí, pero que dependen de la cantidad de tiempo y energía que tengan el animal. Por un lado, la hipótesis del exceso de energía propuesta por Kumen y Goodall en 1985 predice que los animales que tengan más tiempo y más energía, más tiempo libre y más energía, o sea, más satisfechos sus necesidades, tendrán más probabilidades de innovar. Estos serán, por tanto, animales que están en cautiverio bajo cuidado humano, en los que pues, están encerrados en un lugar, tienen todo el tiempo del mundo y sus necesidades están cubiertas. También los que más van a innovar son los de mejor condición corporal y los más corpulentos, los que sean más grandes, los que sean de alto rango social y si hay dimorfismo sexual, los que sean del sexo más grande. Y con respecto a la edad, predicen que innovarán más los jóvenes si hay cuidado parental, es decir, si estos jóvenes tienen todos los recursos, todas las necesidades cubiertas. En cambio, la hipótesis del mal competidor, propuesta por Lalan y Red en 1999, predice todo lo contrario. Cuanto más tiempo tenga y energía, menos van a innovar. ¿Y esto por qué? Resaltan los costos que tiene la innovación. La innovación es rara, pero es rara por alguna razón. Y es que cuanto más se innova, más riesgo tienes de que seas depredado, por ejemplo, porque te expones más al explorar, al ir a otros ambientes, adaptarte a ambientes nuevos, te expones a más riesgos o también a envenenarte si estás probando comidas diferentes, alimentos nuevos. Entonces, ellos dicen que la innovación solo surge en determinadas situaciones en las que los beneficios son más altos que los costos. Y esto es cuando se necesita energía, cuando estás en las peores condiciones y ya no tienes otro recurso por el que competir. Y eso sería más en animales que están en libertad e innovarían más, pues todo lo contrario, los que son de menor peso, los pequeños, los de bajo rango social, sexo más pequeño, y también predice que innovarían más los jóvenes que los adultos, porque los jóvenes tienen más costos metabólicos y entonces pues incurren más en riesgos adicionales para poder sobrevivir. Sin embargo, hay que tener en cuenta que estas hipótesis no han sido corroboradas todavía por la evidencia. Hay estudios que respaldan a una en unas especies y a otra en otras especies, y se necesitaría más investigación para poder determinar con precisión cuál sería la explicación de la emergencia de la innovación. Son hipótesis por ahora. Entonces, recientemente, en un metaanálisis comparado hecho por Amici y colaboradores en 2019, que trata de dar luz sobre estos mecanismos de innovación, buscó la palabra innovación en bases de datos entre los artículos publicados en 1970 y 2018. Y bajo ciertos criterios, como que sean del área de psicología, que sean animales, que sean de conducta, etcétera, seleccionaron a 148 artículos y compararon los rasgos predichos por estas hipótesis más otros factores individuales que pueden ser predictores. Hicieron un modelo lineal mixto generalizado y vieron, en general, los resultados fueron que innovan más los animales de mayor edad. Esto es algo que no estaba hasta ahora en las hipótesis planteadas y que pues estaría en contra de lo que predeciría. Además, encontraron cómo predice la hipótesis del exceso de energía que los de mayor sexo, o sea, el sexo más grande, si hay dimorfismo sexual, serían los que más innovan y no habrían diferencias en cuanto al rango social. En cuanto al entorno, es decir, si están en cautiverio o en libertad, también interactúan los factores individuales, encontrando mayor peso en el modelo de los factores de edad, sexo y rango en la misma dirección que la hipótesis del exceso de energía. Si estos animales vivían en cautiverio versus los animales que vivían en libertad, a excepción de la facilitación social, la cual tuvo más peso si esos animales vivían en libertad. Esto quiere decir que los animales que estaban en libertad y que tenían facilitación social, es decir, que tenían otros individuos a su alrededor cuando surgía la innovación, eran los que mayor probabilidad de innovar tendrían. Sin embargo, concluyen que en el modelo tenían más peso otros factores, como la neofilia, la persistencia y la exploración. La neofilia, para explicarla con un ejemplo, puse a este perro con un juguete nuevo, con el cual está muy contento y interactúa mucho. La neofilia sería la atracción de ese perro por los juguetes brillantes, por los juguetes nuevos, por cualquier cosa en el ambiente que sea nuevo. Sentir esa atracción sería lo que definiría el rasgo de neofilia. Muchos perros, por ejemplo, si ven algo que es muy diferente a lo que siempre han visto, se pueden asustar, se pueden quedar parados, pueden no querer interactuar con eso, y en cambio otros, eso sería neofobia, en cambio otros enseguida irían a por el juguete del otro perro, ¿no? El que es nuevo, eso sería neofilia. Persistencia sería los intentos de resolver el problema o el tiempo total invertido en resolver el problema. Cuanto mayor sea esos intentos o ese tiempo, más probabilidad habrá de resolverlo. Por tanto, los animales que más tiempo interactuaron con la tarea, más innovadores fueron. Y lo mismo con la exploración. Los animales que más exploraban, más conductas diferentes hicieron, más se desplazaron por el ambiente, más probabilidades tuvieron de innovar. Entonces, haciendo una recopilación de toda la revisión bibliográfica, los principales mecanismos que se han encontrado como los de mayor peso que propician la innovación son respuestas a la novedad de tipo neofílico, o sea, atracción por la novedad, la exploración o la motivación intrínseca por explorar, en los que la investigación de objetos y del entorno aumentaría la tasa de encuentro de situaciones y objetos novedosos y permitiría el descubrir nuevas oportunidades para innovar. La persistencia de resolución, que sería el número de intentos o tiempo invertido en interactuar con la tarea, la facilitación social, la flexibilidad conductual, que sería la inhibición de respuestas existentes que han sido previamente exitosas para dar paso a nuevas que puedan solucionar ese problema de una forma diferente. Sería como lo contrario de la rigidez conductual. El insight y la espontaneidad, que sería la comprensión del problema y la planificación de la respuesta para resolverla de forma espontánea sin un aprendizaje por ensayo y error. El aprendizaje asocial o individual, que sería el aprendizaje de affordances o de posibilitadores de acción, de elementos relevantes para resolver la tarea previamente a su exposición, así como otros factores interindividuales como los que hemos visto, la edad, el sexo, condición corporal y rango de dominancia, pero esos ya serían de menor peso. El objetivo principal de mi tesis, y que aún estoy desarrollando, es identificar los mecanismos promotores de innovación en ratas a través de su exposición a una tarea-problema. Se manipularon y evaluaron diferentes factores influyentes, principalmente las condiciones ambientales en los que se alojaron a ratas en diferentes tipos de ambientes, el aprendizaje social, en los que se entrenaron a ratas a diferentes conductas, tal y como lo hizo Epstein con las palomas, y la flexibilidad conductual se evaluó en una tarea aparte, en la que se tenía que cambiar la estrategia de resolución previa. Y además se evaluaron los efectos en la innovación de estos factores interindividuales, como la exploración, la neofilia, la persistencia y la espontaneidad. La hipótesis principal era que cuanto mayor complejidad del ambiente y cuanto mayor aprendizaje relacionado con los elementos relevantes para resolver el problema, va a haber un mayor repertorio conductual, que sería esto, más conductas diferentes, que generaría que se pudieran combinar más de forma diferente, por lo tanto, explorarían más. También encontraríamos un mayor intento de resolver el problema, mayor neofilia y mayor insight, que daría lugar a una mayor flexibilidad conductual e innovación. La tarea-problema, la tarea-problema a la que se expusieron las ratas fue esta caja en la que las ratas se colocaron en el suelo, tenían que subir por la rampa, cruzar el puente y tirar una cuerda en la que su extremo había atado alimento, que eran salchichas. Por su saliencia olorosa se eligió este alimento. Como esta rata de aquí está resolviendo el problema de esta manera. Entonces, el procedimiento consistía en que todas, desde que nacían, estaban en las mismas cajas y a partir del destete, en el día 21 postnatal, se alojaban de forma aleatoria en diferentes cajas ambientales. En el día 75 se empezó el entrenamiento de las condiciones de entrenamiento y en el 90 se empezó el test, que consistió en 4 sesiones de 10 minutos. En estos 10 minutos, las ratas tenían posibilidad de resolver la tarea tantas veces como el tiempo les fuera posible. Se iba reemplazando el alimento en la cuerda. Y la prueba de flexibilidad conductual consistió en cambiar la posición de la cuerda desde el puente, cambiarla al techo. Por lo que las ratas tenían que desde el suelo subir la rampa, cruzar el puente y desde el puente salir al techo de esta manera, como esta rata, y tirar la cuerda de forma vertical, y de la misma manera que desde el puente. O sea, se requería una conducta más. Sin embargo, algunas ratas fueron muy flexibles y resolvieron de 1000 maneras, como por ejemplo esta aquí, estirándose desde el puente con la cola agarrada del techo para equilibrarse, o intentando trepar en el techo. Alguna lo consiguió. Todas estas resoluciones fueron codificadas y analizadas en cada una de las condiciones ambientales. Las condiciones ambientales fueron 6. Una aislada en la que vivían las ratas de una en una social en las que vivían en una caja de 4 ratas sin ningún otro tipo de estímulo, solo social. 2 condiciones enriquecidas, una enriquecida de forma que los elementos no estaban relacionados con la tarea. Habían cosas básicas de enriquecimiento como una rueda de actividad, túneles, refugios, y otro enriquecimiento que se llamó condición promotora, en la que también vivían 4 ratas, pero había la posibilidad en este ambiente de desarrollar las conductas relacionadas con la tarea problema, como por ejemplo trepar, ya que había altura, en esta no, o interactuar con cuerdas. No, tal vez no había nada para tirar, pero sí podían roerlas, podían agarrarlas. Y los mismos artículos, ¿no? La rueda de actividad, tubos y refugios. La condición de entrenamiento conductual fue de 2 tipos, uno relacionado con el problema y otro sin relación. El relacionado con el problema se le entrenó las conductas per requisito, tal y como lo hizo Epstein con palomas, en las que se dividieron 3 conductas, la de subir rampa, cruzar puente y tirar verticalmente la cuerda. En este video se ve cómo hice el entrenamiento. Si sé ponerle play. Ay. A ver. No, pues no sé. A ver. Aquí voy reforzando a la rata cuando sube y cuando baja en diferentes lugares y a diferentes alturas, para que suba de forma direccionada y baje de forma direccionada. En el de cruzar puente, el requisito cada vez iba aumentando. Al principio reforzaba solamente que me siguiera con las 2 patas delanteras, que las pusiera encima de la madera, y más tarde iba subiendo el requisito. Ya tenía que tener las 4 extremidades encima de la madera para que lo reforzara. Y después iba reforzando que fuera de un lado a otro. El criterio de aprendizaje fue 20 conductas de cruzar puente en cada una de las 3 conductas objetivo durante 4 sesiones consecutivas. En la de tirar cuerda, al inicio intentaba atraer a la rata hacia la cuerda y reforzar que estuviera cerca de la cuerda. Y ya que ya que comía cerca de la cuerda y que interactuaba con la cuerda, cada vez ponía un reforzador que no era el mismo que el de la tarea problema, más abajo de la cuerda. Aquí no se ve la rata, está hacia acá. Aquí ya tira completamente la cuerda, unos 5 centímetros, que era la misma conducta que se le requirió en la tarea problema. Y por último, la última condición era el entrenamiento conductual, entrenamiento de una conducta, pero que no estaba relacionada con el problema, que se eligió la conducta de palanqueo en cajas de Skinner, se entrenó a presionar la palanca izquierda y después la derecha en un tiempo fijo 30 segundos, razón fija 1, y se iba aumentando el tiempo fijo cada vez más hasta que solo se reforzó si apretaba la palanca, la razón fija 1. Y el criterio fue de 150 respuestas durante 4 sesiones consecutivas. En este otro video, a ver si deseo poner play otra vez. Bien. En este se ve cómo se fueron codificando las conductas mediante un programa, se grabó todo y se hizo un etograma en las que están todas las conductas que me interesaban más para ver los factores individuales de neofilia, persistencia, todos, ¿no? Y se iba codificando el lugar donde estaba la rata, si comía, cómo había comido, si había tirado la cuerda previamente, dónde comía, si estaba en rampa. Esta rata, por ejemplo, resolvía desde la pared, entonces se codificaba que comía desde la pared sin haber tirado la cuerda. Todo esto en cada una de las sesiones. Esta, por ejemplo, es la de flexibilidad conductual, en la que la rata sale al techo, como ven. Es una rata enriquecida. Y tira la cuerda desde el techo. Primero la roe y al final la acaba tirando. Y resolviendo la tarea. Y bueno, está lo mismo, es otra forma de resolverla. Sin embargo, esta pues no pudo acabar de salir al techo y acabó resolviendo el problema, pero como ven, de estas maneras tan diferentes entre ratas. Esto para que vean la cantidad diferente de conductas que pueden llegar a hacer y de formas de resolver inesperadas que son parte de esta definición de innovación. Y bueno, los resultados fueron que en innovación, es decir, en la frecuencia promedio de resolución del problema, las condiciones que más resolvieron fueron la prerequisito, las que se fueron entrenadas a las conductas prerequisito para resolver el problema, seguidas de la promotora, la enriquecida relacionada con el problema, la enriquecida sin relación con el problema, que sería esta, la de palanqueo, la social y la aislada, tal como lo predijimos en la hipótesis. En las tareas de flexibilidad conductual, los resultados fueron muy diferentes para la condición de prerequisito. Pasó de ser la que más resolvía a la que menos cuando la cuerda se colocó en el techo. En cambio, las condiciones de enriquecimiento ambiental no tuvieron diferencias significativas y ambas fueron las que más resolvieron la tarea. Todas las demás no resolvieron esta tarea. Por tanto, hubo rigidez y el ambiente no propició que hubiera un nivel de flexibilidad y que se pudiera dar a aparecer la innovación, a diferencia del enriquecimiento ambiental. En exploración, la frecuencia que se definió como la frecuencia promedio de conductas diferentes, los resultados fueron similares, pero un poco más sin diferencias significativas entre las condiciones de enriquecimiento ambiental y la prerequisito. La de palanqueo estuvo en medio y la aislada y la social a la que menos exploró la tarea. Se hizo un modelo lineal mixto generalizado y se vio que todos estos factores individuales, como es la exploración y los que voy a enseñar posteriormente, tuvieron un peso significativo en la aparición de innovación. La neofilia, vista como la latencia en segundos promedio en interactuar con el elemento relevante para resolver el problema, que en este caso fue la cuerda. Aquí están ordenadas al revés, ya que 600 eran los 10 minutos que duraba la tarea, por tanto, si la latencia era de 600, fue que no interactuó con la cuerda durante toda la sesión, y las que más rápido interactuaron con la cuerda fueron la prerequisito, siguiendo el mismo orden, pero a la inversa. En persistencia, definida como el tiempo promedio de interacción con la cuerda, se vio un poco similar al factor de exploración, pero con la misma tendencia en el que las conductas de enriquecimiento ambiental eran similares a la de prerequisito, mientras que palanqueo, social y aislada eran las que menos tiempo interactuó con el elemento relevante para resolver la tarea. O sea, el que menos intentó resolverla. Y la espontaneidad, que fue el rasgo que tuvo un mayor peso en el modelo mixto generalizado, fue la que explicó, y unos 100 segundos fue la media promedio de resolución de la condición de palanqueo, con el mismo orden. Y bueno, en conclusión, la complejidad ambiental y el aprendizaje social relacionado con los elementos relevantes del ambiente son mecanismos promotores de innovación. El entrenamiento, perdón, es que se cambia solo. El entrenamiento previo de comportamientos relacionados con el problema fue la condición que más facilitó la resolución del problema, pero que generó rigidez conductual a la hora de resolver otros tipos de problemas, incluso problemas muy relacionados. Y el enriquecimiento ambiental fue el que más facilitó la emergencia de innovación y de flexibilidad. La condición social y aislada fue la menos promotora de innovación, hubo una alta inactividad y neofobia, baja exploración y persistencia y alta rigidez conductual. Y bueno, espero que hayan entendido todo y si no, pues abren las preguntas. Muchas gracias por su atención. Cualquier pregunta, estoy encantada de resolverla.
Muy bien, Aida, pues muchas gracias. Lauren, ¿tenemos alguna pregunta en las redes sociales? En Facebook, en YouTube, también pueden utilizar Twitter. Entonces, ustedes me van avisando, pero mientras, Aida, me parece, yo sí tengo algunas cosas, me parece que es, pues antes que nada, te debo agradecer la grandiosa charla acerca de los mecanismos de innovación. Me parece, personalmente, quiero decirte que tu charla fue súper interesante, no solo por compartir los resultados que nos acabas de mostrar, pero también por explicarnos en detalle cuáles son los principales mecanismos promotores de innovación. Me parece que fue una presentación bien compleja que va de lo teórico a lo práctico y que nos mostró toda la amplia gama de posibilidades que hay en esta área, ¿no? Entonces, personalmente me pareció una charla muy, muy completa. Bueno, mientras llegan algunas preguntas, yo sí tengo una. Primero es, bueno, los resultados parece que tus resultados, si no estoy mal, parece que apoyan el modelo descrito por Amici. Sin embargo, ¿tú cómo podrías explicar, por ejemplo, las diferencias entre los grupos que son los enriquecidos y los grupos que no son los enriquecidos, pero aquellos que mostraron mayor rigidez? No recuerdo el nombre que usaste, pero aquellos que generan mayor rigidez. ¿Tú cuál crees que sea la explicación de esto?
Bueno, la hipótesis era que una complejidad ambiental va a generar que haya mayores posibilitadores de acción, haya más un aprendizaje asocial mayor, ya que van a haber más elementos de los que interactuar y aprender, y a su vez también un mayor repertorio conductual, porque el ambiente propicia o da la oportunidad de hacerlo, a diferencia de los demás ambientes que no había ningún otro estímulo, no podían ni siquiera tener la oportunidad de desarrollar conductas como trepar, ¿no? Porque estaban en una caja que no les permitía. Entonces, cuantos mayores cambios en el ambiente, ya que el enriquecimiento ambiental también consistía en eso, en hacer todo un protocolo de enriquecimiento en el que se iban cambiando los elementos de posición, también se les incluía otros juguetes como papeles, pelotas. Entonces, que haya más cambios en el ambiente, como se postuló en la introducción, que eran elementos ecológicos relevantes, sería la hipótesis que yo tengo principal. La complejidad y el aprendizaje de conductas.
Pues prácticamente encuentras lo que la hipótesis que tú querías.
Sí, Laura. No te oímos ahora. Sí. Sí. Es muy buena pregunta. Yo creo que sería muy similar a, pues tal vez los recursos económicos, ya que sería algo, pues eso que predicen las hipótesis de como el exceso de energía o el mal competidor. Si tus necesidades básicas no están satisfechas y tienes mucho tiempo libre o poco tiempo libre. Eso sería algo que en humanos todavía no se ha investigado tanto, y sería muy interesante ver si los que tienen mayores recursos económicos y por tanto pues, quiero pensar que tienen más tiempo libre y las necesidades básicas más cubiertas, serían los que más innovarían, o por el contrario, sería la gente que más necesidades tiene, que no tiene tiempo, tiene que estar inventándose cosas nuevas para conseguir esos recursos. Eso me parece muy interesante, pero no está comprobado. Y otro caso que también me genera mucha curiosidad en humanos es el clima. El clima cambiante, o sea, la gente que vive en el Ecuador, que no hay estaciones, que no tiene que preocuparse por los recursos que van a venir en otras estaciones y pues que no tienen que comprarse ropa para el invierno, no necesitan calefacción. Se ha relacionado con niveles más altos de violencia. Y eso se ha relacionado con la impulsividad también, porque no tienen que estar planificando, viven sin consecuencias a largo plazo. Bueno, esa es la hipótesis, ¿no? Entonces, esa sería una hipótesis por lo que las personas que viven en el Ecuador, donde hace muy buen tiempo, donde hay más recursos, hay más alimento, hay cultivos, frutas, pues tienen una sociedad más violenta que tal vez los que viven en el hemisferio norte, que hace más frío, que necesitan una casa sí o sí para sobrevivir. Entonces también me parece muy interesante esa hipótesis de que el clima cambiante es promovedor o promotor de innovación.
Muy bien, súper interesante.
Ahí la violencia pues sería otro factor. Sí.
Sí, entonces Alejandro Macías nos envía esto. Dice, ¿existe evidencia de si existen diferencias en el momento del desarrollo en que se expone a diferentes niveles de enriquecimiento ambiental? Como por ejemplo, que el enriquecimiento ocurra solo en etapas tempranas y no en etapas adultas o viceversa.
Sí. Hay estudios, bueno, de hecho, pues un estudio de Alejandro Rodrigo lo evidenció, pero sí hay más evidencia de que si hay enriquecimiento ambiental en las etapas de desarrollo, como fue en el caso de mi estudio, es más fácil que estos efectos perduren a través del tiempo, que no haya una reversión, que si hay un enriquecimiento solo en la adulta y no en el desarrollo. Lo que hizo Alejandro, bueno, no sé si lo quieres explicar tú porque es tu estudio, pero lo que hizo Alejandro fue poner a ratas en aislamiento durante el desarrollo y a otras en enriquecimiento. Y luego, al contrario, cuando fueron adultas, las que estaban en aislamiento pasaron a enriquecimiento y al contrario. Y vio que los efectos de enriquecimiento en el desarrollo perduraron en las tareas, en ansiedad, ¿no? En la tarea del campo abierto. Y pues las que no fueron enriquecidas durante el desarrollo siguieron siendo más ansiosas a pesar de haber estado enriquecidas en la adultez.
Así es. Muy bien. Laura, no sé si tengamos tiempo para otra pregunta. Parece que Santiago sí mandó varias. ¿Tenemos tiempo todavía o se las envío directamente a Aida? Tú dime. Muy bien. Es un poquito larga, entonces dice, Santiago Castielo de Obeso nos pregunta, dentro de la distinción entre explotación y exploración, si mal recuerdo, la exploración puede ser conceptualizada como conductas al azar por otras alternativas. Sin embargo, dadas tus demostraciones experimentales, me pareciera que tus animales no generan conductas al azar. Pareciera como si que tus animales, un tipo de exploración dirigido a metas. Quizá alguna distinción técnica de esto, no la conozco. ¿Tienes alguna opinión sobre la exploración siendo un proceso al azar en comparación de un proceso orientado a metas?
Sí. Sí, de hecho, es súper buena pregunta. Es algo que ya tuvimos en cuenta a la hora de diseñar el estudio, pero que no conté en este congreso porque era demasiado largo, ya eran demasiadas variables, pero lo que hicimos para diferenciar entre exploración dirigida a metas y exploración fue no solo exponerlos a 4 sesiones de la tarea problema con alimento, sino que después las expusimos a 4 sesiones más sin alimento, a la misma tarea. Y a la mitad del grupo al revés. Primero, en exploración, 4 sesiones, y después 4 sesiones con alimento. Eso se llamó motivación intrínseca versus motivación extrínseca. La intrínseca es explorar al azar, como decías, solo porque pues hay ese espacio, ¿no? Y se empiezan a mover, pero no hay alimento en esa tarea. E incluso se vio el mismo patrón, aunque un poco menos, muchas menos resoluciones, pero sí se vio el mismo patrón de las condiciones de resolución en exploración, o sea, de forma aleatoria, y que cuando hubo alimento en la tarea, que eso se llamó motivación extrínseca.
Pero de lujo, sí, no, completamente de acuerdo contigo. Tenemos una última, si no te molesta. Dice, Navarro nos pregunta, ¿cómo se dio cuenta que los animales de mayor edad innovaban más que los de menor edad?
Bueno, eso fue en el metaanálisis de Amici, ¿verdad? Depende qué estudios. Ellos, como hicieron un metaanálisis, lo que hicieron fue cargar todos los datos de esos 140 y tantos estudios, todas las edades que encontraron más innovación. Entonces, eso lo analizaron ellos, no sé exactamente cómo, pero fue una recopilación de datos de artículos en la bibliografía que decían qué edad tenía y si había resuelto o no el problema. Puede ser un fallo de muestra de que hay más tendencia por investigar jóvenes o más tendencia por investigar adultos. Entonces, pues la muestra va a ser más grande en adultos y por eso se puede ver esa diferencia. Se necesita más investigación, particularmente de la edad, para poder corroborar ese dato. Pero lo que viene en la literatura, lo que encontraron en el metaanálisis fue eso. No sé si responde a la pregunta.
Sí, definitivamente, completamente de acuerdo contigo. Aida, de nuevo, mil gracias por tu grandiosa presentación. Si llegaran a haber más preguntas, te las haré llegar en su momento.
Si puedo dar mi mail o, bueno, no sé si ya lo tienen, pero...
Sí, cualquier cosa, nosotros redirigimos las preguntas hacia ti. Y si alguien pregunta, nosotros le damos tu correo y cualquier cosa así para que se mantenga el contacto. Mil gracias de nuevo. Antes de ir a un descanso, me gustaría darles un breve anuncio antes de la presentación del doctor Bruno Klug. No olviden que para obtener el certificado de asistencia deben de registrarse y completar el formulario en Google. Ya les dejaré el enlace específicamente de la charla de Aida. Lo pueden ver publicado en Twitter, en YouTube o en Facebook. Entonces, por favor, métanse, resuelvan el cuestionario y eso es todo. Entonces, vamos a una pausa y regresamos. we will announce the winner of the Walden Modular Equipment Award at the end of the meeting. And if you have any question, don't hesitate to contact us through the chat, the YouTube channel, Facebook, or Twitter account that is @_GECYZ. Please enjoy the presentations. Lo primero que, antes que nada, quiero decir que tuvimos un problemita con uno de los médicos, uno de los doctores, por lo tanto vamos a adelantar la sesión de carteles. Lo primero que tienen que hacer para acceder a la plataforma es ir a la página del GECC, es www.ae-gec.com/Congreso. Eso es de nuevo www.ae-gec.com/Congreso. En la parte superior de la pantalla encontrarán una pestaña que dice Sesión Carteles. Den clic en la pestaña y lo redirigirá a la página en donde los ponentes han preparado el cartel y una breve explicación del mismo en un video. En esta página también podrán encontrar un chat por el cual podrán comunicarse con los ponentes de los carteles, de tal forma que tanto los participantes pueden enviar las dudas o los comentarios a los ponentes de los carteles. Para ingresar al chat deberán colocar su nombre y primer apellido sin espacios, es súper importante. También es muy, pero muy, muy importante que todos los participantes y ponentes utilicen únicamente la sala que dice #carteles_GECC, únicamente esa. La dinámica tendrá una duración de 1 hora y después de finalizar dicho periodo retomaremos las ponencias, iniciando con la participación del Dr. Bruno Klug. Anunciaremos el ganador del premio Walden Modular Equipment al final de la reunión. Si tienen alguna duda, de nuevo, no duden en contactarnos por medio del chat de YouTube, en Facebook o bien en Twitter. La cuenta de Twitter es @_GECYC. Espero que disfruten sus presentaciones y cualquier cosa andamos por aquí. Gracias.
Muy bien, muchas gracias. En breve regresamos con la presentación del doctor Bruno. I hope you enjoyed the poster's presentation. I'm super excited to know who will be the winner of the special prize that our friends from Walden Modular Equipment has prepared. If you are interested in animal research, do not forget to sneak in Walden's webpage. Is walden-me.com. Y bueno, español now, Spanish. Antes que nada, espero que hayan disfrutado de la sesión de póster. Estoy muy emocionada de saber quién será el ganador del premio especial que nuestros amigos de Walden Modular Equipment han preparado. Si están interesados en la investigación con animales, no olviden visitar la página web de Walden, walden-me.com. Okay? Well, let's talk about science with Bruno. It's our pleasure, Bruno, to have you here with us. Let me introduce you to the audience. Bruno studied his PhD at Psychiatry University Hospital Zurich in the Experimental and Clinical Pharmacopsychology Lab. His postdoctoral research was at Pontifical Catholic University in Rio Grande do Sul. And now he's a full-time professor at University of Minot. He has written 22 articles. He's very prolific, and his work has been cited almost 300 times, which is amazing. In Spanish now, Bruno estudió su doctorado y luego en portugués, and after that Portuguese. Bruno estudió su doctorado en el hospital de la Universidad del Hospital Psiquiátrico de Zurich, en el Laboratorio de Farmacopsicología Clínica y Experimental. Su investigación postdoctoral fue en la Pontificia Universidad Católica de Río Grande do Sul, y ahora es profesor de tiempo completo en la Universidad de Minot. Él ha escrito pues 22 artículos, es muy prolífico para su corta, es muy prolífico. Su trabajo ha sido citado casi más de 300 veces, así que es un placer tenerlo aquí con nosotros. Thank you so much, Bruno, to be with us. We are so happy to have you here. So now it's all yours, the microphones.
Thank you thank you. Well, first of all, thank you very, very, very much for the invitation. I'm super happy to be here with you, sharing a bit of my latest work in the first International Congress of Cognition and Behavior, and I'm super happy, really. And I am super sorry as well. I really messed up the time zone stuff. This is the joys and the kind of the bad things about telework and home office. You can get messy around the world. But anyways, now we are here and everything seems to be working perfectly fine. I will share here with you my screen. So please just tell me if you are already seeing my slides. Can you see?
I can see your slides now.
Perfect. So great. So as I told you, this is the latest study I have been working. It was already peer reviewed. It's meant to be published soon, I hope, and it was a quite different study to me. It was the first time I was working online with online surveys, and it's not that clinical study, but I hope that it will bring some light on an online survey and how can we actually use online survey to do huge, let's say, huge experimental sets, if we can say that it was actually experiment. But I hope you enjoy. So actually, everything starts, as you know, I was just working as you guys. I was in my university doing my data collection, calling people, visiting people, bringing people to the lab, and then suddenly we have the pandemic. And then everybody goes home and we are meant to stay at home for social distancing. So I don't know how it works. In Mexico, I don't know how it works in other countries like Portugal, where I am right now. But I know that in Brazil, it works not really good, actually. As soon as this social distancing and this lockdown ideas start to gather some political debates. And this debate was mainly based on the fact that the social distancing in a long-term perspective would not be that good, or at least not for the economical side, of course. And what happened in Brazil was that many people start saying that the social distancing would not work good because most of people would not be able to do home office as we are doing right now, and therefore many people would lose their jobs and they will have lots of problems or financial problems. What people were also saying a lot in Brazil, a very widespread assumption or idea that was around in Brazil, is that people who are not financially comfortable, let's say, or do not have enough money, would struggle more to attend social distancing measures. So this was something that people were saying in Brazil. Look, we cannot do that because, you know, this guy here needs money, so he needs to work, therefore it's not going to work. And then together with this, there was also an idea in Brazil, many people saying that actually the risk of the coronavirus is not that bad. People were saying that, you know, actually who is getting ill, it's really people who, it's a like the risk group, right? So people that are elderly or that already have a disease or so on and so on. So actually most of the population will not suffer from it, so therefore we should not attend social distancing as people are suggesting. So this kind of reasoning was really a debate, and from the political side through friendships and dinner talks. So this was something quite huge. And this was actually what popped up in our minds when I was working in Brazil. We thought, okay, although there are many political, many healthy, many economical stuff, there is actually an individual dilemma here, right? So basically what people are facing right now is like this decision, like super simple, I know, I'm simplifying at most, but the decision was more or less like this. Should I stay home with absolutely no risk of contamination and possibly not having enough resources, so possibly losing my job or possibly not having my salary? Or should I keep my routine, you know, let's just keep my normal routine, go to work out of my house, and of course keep my salary, keep my resources, but somehow, of course, increasing the possibility of contamination. So kind of this dilemma seems to happen for many people in Brazil. And this is, of course, a very complex dilemma because we know that there are many socioeconomical factors that might interact with perception, risk perception, actually. So how do I think that coronavirus might impact my health? But also, how do I think that I really need money, or I will really lose my job if I'm not going to work or working at home? So a lot of different beliefs were behind this. And then we thought, okay, maybe we could try to investigate this in a more experimental way. I mean, I'm really doing like this because, of course, we know it's online survey, it's far from our labs, it's far from our comfortable zone. But can we try at least something a bit more precise in terms of behavior? Can we try to map? So we start this study, and this study had three main aims. The first one was to investigate what degree of risk of infection with coronavirus or COVID-19 is necessary on average so that people will intend to stay home, even if if staying home means losing their salaries, you know. So we want to know how many or how much risk of contamination is necessary. So people will say, look, okay, if it's 80% risk of contamination, I'm not going out, doesn't matter the salary. This was the first aim. Our second aim was to understand, okay, but which sociodemographic factors may influence this tolerance, this risk tolerance, let's say, or the maximum tolerated contamination risk, as we call in our paper. Maybe, I don't know, maybe if I'm really I have a really good education, maybe I have a good idea about the real risk of getting contaminated, and then maybe I will go out or I will stay home. And then our third aim was to establish a predictive model of risk-taking and risk-averse behaviors in the context of the pandemic, because we really believed, and when we were discussing about this study, we thought, okay, look, it's really interesting to see associations, it's really cool to see what's happening, but can we predict who are those people that are really going out and who are those people that are really staying at home, or at least reporting staying at home, right? So this was our third aim. To do so, of course, we had to develop some sort of questionnaires, right? So we developed, like we call the COVID-19 risk aversion questionnaire. Is not that creative name, but we basically did this questionnaire based on two main, let's say, theories, right? The expected marginal utility theory and the axiomatic approaches. So basically, we know that as much reward I have, less attractive it is to me. So this is the expected and marginal utility that we try to keep in our minds. And we also know that in the end, we are always measuring behavior. So we need to try to figure out if people are being irrational when they are doing their choices, which means that we need to somehow use some axiomatic approach. Because let's say that if I prefer strawberries than bananas, and if I prefer bananas than grapes, I cannot prefer strawberries than grapes. Otherwise, I will be, I need to prefer strawberries than grapes, because if I prefer grapes than strawberries, I am being irrational from the economic point of view, of course. So we had these two ideas in our mind. And again, our main question was, okay, how much risk of being infected is necessary so that people do not intend to leave home, even when it may mean losing their salaries or their resources. This was the main idea behind. Cool. So let's show a bit the method, and then I will already show a lot of results. And please let me know if you, at any point, if you have any doubt, you just can interrupt me, okay? It doesn't necessarily need to be in the end. So first of all, we figure out that, okay, if we want to do this kind of questionnaire involving, including salaries, we need to know the salary range, right? We need to know the income range of each participant. And then we create this 6 levels, so this range, which is from less than 3,000 reais till more than 15,000 reais. And then we use the purchasing power parity, which is a tool from the World Bank to convert this value. So it's not exactly, of course, it's not like the real conversion, like this value here is not exactly the real conversion in dollars, but actually means how much I can buy with this amount of reais in dollars. So if I would live, of course, in United States. So meaning that with less than 3,000 reais would be the same as living in US, with $1,300. And then, more or less, based on Brazilian reality, of course, we kind of classified these ranges in lower low class, upper low class, and so on. So we have 2 lower classes, 2 middle classes, and 2 high classes. So let's imagine that someone it's on this second class, right? So someone that in Brazil gets a salary of 3,000 to 5,000 reais. Okay, it's a really common salary in Brazil. So let's imagine this. This participant in our survey, he would face several questions, but these questions were divided in two big compounds, or we call here salary items, salary ranges. I'm sorry. So this means that first, this person will see such kind of question, offering her or him half of a salary. So if the participant receives between 3,000 to 5,000, we then ask them, okay, what would you choose? Would you leave home for a salary of almost 4,000 while being exposed to a 5 risk of infection? Or would you prefer to stay home with no salary and no risk of infection? So we are offering here half of the salary, right? I mean, it's the average, of course, but so more or less. And then people would also need to answer the other question, the full salary offer. The full salary offer was, would you leave home for a salary of 4,995, more or less, so almost the entire range, right, 5,000, while being exposed to a 5% risk of infection? Or would you prefer to stay home with no salary and no risk? So the second alternative is the same. What changes is the first. Sometimes it's half of the salary, sometimes it's the full salary, let's say, or almost the full salary. And then what we did was, let's take the laser pointer here. So what we did was to create 8 different risks of contamination. So we asked people 5% risk of contamination, 10% risk of contamination, 15%, and so on, till 80% risk of contamination. So this means that here we are saying or asking people, would you leave home to work if the chances of getting infected by COVID-19 is 80% to get your full salary, or would you prefer to stay home? This would be this alternative here. And we also have all the half salary offers, right? So the same risks, but then with half of the salary. Would you leave for half of the salary depending on this risk? And then we use more or less a similar approach as is used for probabilistic discounting or delay discounting. And then we order all the alternatives, and then we try to figure out, okay, where is the turning point, right? Where is the moment that people would say, okay, 5 risk, I prefer leave home. 10 risk, I prefer leaving home. 25% risk, I prefer leaving home. 35% risk, no, I will not go home, I will not go to work. I will prefer staying home. I will not expose myself to 35% risk of contamination. So basically similar as other probabilistic or temporal paradox, right? Usually this turning point is called, or is usually called as indifference point, right? Here we call the K estimates. We thought it was the best best name for it. So we call K estimates, and it depicts the maximum risk of COVID-19 contamination that participants are willing to tolerate to leave home and guarantee their salaries. So far, so good. Please let me know if it's going okay, right? So this was the main questionnaire. I'm just coming back here. 16 questions that were randomized across all of them. Okay, so all these 16 questions were randomized for each participant, and the amount of salary depends, of course, in the salary range that people actually want. So the household income. And then we also ask people in the same questionnaire. We also ask, okay, but how? We ask them the perceived risk of becoming severely ill if infected with COVID-19. What does it mean? Of course, I mean, the risk of getting contaminated can be 50%, let's say, extremely high. Okay, if I go out, the chance of getting contaminated, 50%. It's a lot. But imagine that I think that even if I get contaminated, I don't know, I think I'm not going to the hospital. I think I will have like a very, very bad flu, and I will stay at home for 2, 3, 4 days, really, really bad. And then after 6 days, I will feel okay again, and then I just have to stay home. So does not mean that getting the virus, I will be ill. So we ask people from 0 to 100, this perceived risk of becoming really ill. And we also ask people about their financial health. So financial health, it's a very complex construct, but we try to summarize in 2 main questions. One is the amount of savings in the end of a regular month. Of course, not absolute values, but actually the percent, right? So how much savings each participant believes can save, and the fear that the saving would not last. So how much I think that actually my money will save me if I need. For how long can I survive without getting money? Then we had several social demographic factors. So the main ones, or the most important ones for us here, were age, sex, being or not a health-related professional, being unemployed or retired, educational level, of course. And we also had some COVID-related factors. So, for example, we asked people if they were, or if they had or have flu-like symptoms in the moment, because maybe someone is with a flu and that will be really worried. And we also asked people if they were part of any risk group for the severe respiratory syndrome. And we also ask people about their contact. How much contact do they have with the COVID-19? This variable actually was based on 4 other variables. The first one, if the participant already got the diagnosis, the formal diagnosis of COVID. The second one is that if the participant believes that he or she was infected before, so he do not have the formal diagnosis, but believes that has or had the virus. If the participant had or has any relative infected, and the closeness belief. Closeness belief is like, okay, I'm not infected. I don't think that I am infected, but I think that a lot of people around me are infected. So how close I am from people with COVID. For example, health professionals in general, they would say they are pretty close from people with the COVID, right? So their closeness will be really high. And then our data analysis. Our data analysis was was done in several steps. And here I try to summarize. So actually we had around 11,000 answers in this questionnaire. But when you do like online surveys, most of people are not finishing, or many people answer anything which makes no sense, even for the basics. For example, age, I don't know, 1999. So of course it's 999, makes no sense, or does not answer properly. So from all these almost 11,000, we finished with 8,300 participants, more or less. But then we actually only look for those participants that were reliable in our questionnaire, meaning that we look for all the participants that follow an axiomatic approach. I will show in detail this, how it works, okay? But we only look for rational people in terms of economic behavior, at least. And then with those people here, we run, of course, some descriptive statistics I am going to show soon, and some structural equation model, and also some logistic models, as I will show. Afterwards, we then split the sample. We took 70% of the sample from one side and 30% of the sample on another side. And with the 70% of the sample, so 5,000 people, we create conditional inference tree. It's not really machine learning, but it's kind of a machine learning process to try to create, okay, can we predict who are those people that are super risk aversive or super risk taking? And then if the model works, we then replicated the model in the 30% of the sample to see, okay, if the model here was able to predict, we need to be good enough to tell me from those 2,000 people who are in each group. So this was all the steps we did. So the results we got. First of all, it's important to say that our data was collected from April to May, so it was not really a long period. It was really, really short period. And we can even see here that most of our data were collected right in the first days actually, and then a little bit in the second week here, and then no one like to answer our questionnaire anymore. But anyways, it was a lot of people just right in the beginning. And during this period, this was the cumulative number of deaths divided per the population in Brazil, exactly in the same period. So it was pretty high, but not that high as now. But anyways, there was no correlation. We checked for this data afterwards. So the real reliability that I told you, the reliability is quite simple, right? If I prefer leave home, if I don't care, let's say, if I don't care leave home with 5% risk of contamination, 10%, 15, 25, if I say that I prefer to stay home if the risk is 35% of contamination, I cannot change my mind. And then when the risk is higher, I prefer leave home again. Makes no sense, right? Once the risk reaches a point, most of people should stay in this point, right? So any inconsistency like this was completely discarded. So this was 1,125 people. They were not in this questionnaire. We thought they are not trustful enough. So basically our sample flow, we have no groups in this first moment. And here you can find a bit of the demographics. It's a lot of data, a lot of numbers. So here, to make things easier, most of our participants were or had between 26 and 45 years old. We have 70% of women in our sample against only 25% of men. I mean, in general, women tend to attend research more often, but this was a lot of women in comparison to men. Anyways, most of our participants were had high educational levels, and 1/3 actually of our participants they were health professionals, or they work in related fields. For example, us, right? So, or at least I am a psychologist, but I'm doing research. It's in health. It's a health-related discipline, but I'm not really working the field, right, with the patients. Of course, this reflects our friends, right? So we launched the online survey. Of course, first of people that answer were people related to us. That's why they have a similar profile. Then we check for the proportion of leaving home answers for all the risks of contamination. And as we can see here, it's behaving as we expected. So the higher the risk of contamination, right, the lower the proportion of leaving home intention. Of course, if the risk is super high, I don't want to leave home. I want to stay home, which makes absolutely sense. And also what makes sense is that, higher reward, it's a good motivation to leave home. So higher the reward, higher the proportion of leaving home intentions. So this was only to check whether everything works good. Then we thought, let's now look for the K estimates or the indifference point. Remember, the K estimates are the same indifference point as, for example, delay discounting. So when people change the behavior, and then we saw that for the full salary offers, the blue one here, the turning point was 38% of risk. So people, on average, tolerate 38% risk of contamination, and then they changed their minds and decided to stay home. But when the half salary is considered, then we have 32. It's a bit lower. Of course, with 7,000 people, this is significant. But look, the effect size is quite small, so it's not a great finding, but it's important anyways to mention. We can also see here the distribution or the density of the perceived risk of getting really ill, right? So here what we are seeing is that most of people, or on average at least, people think that if they get contaminated, if they get the virus, if they get infected, they had 38% risk of getting really, really ill, going to the hospital and get really problems with this. So this is how the data more or less worked. But look what an interesting data we have here, actually. We can see that there are many groups around. For example, we know that 18% and 21% of people, look at the top and the bottom of the violin plot here, what they are saying? They are saying that actually really doesn't matter the chance of contamination. Those people will always stay home or always leave home. Doesn't matter the risk and doesn't matter the salaries. So basically what we are seeing here is that 40% of all those people, they already decided, look, I will stay home, doesn't matter what. I will leave home, doesn't matter what. Only 60% of people actually change their behavior as in our questionnaire. Moreover, if you look at here, we see that, okay, the average was 38, but look, most of people, 60% of people believe that the risk of getting really, really ill, it's below 30% or 40%, right? so it's not much. We have only 23% of people that believe this is super high, and we have like 20% of people that put 50%. Here, I really think that this is like people that have no idea. So they say, I have no idea if I'm getting really ill or not, if I got infected. So it's like flipping a coin, right? Maybe I will be ill, maybe not. Let's put 50%. What we can also do is correct these values here. We can correct these values here for this chance here. Basically, I'm just multiplying one by the other. If I multiply my perception of getting severely ill by the chance of getting infected, I will have the real risk I can tolerate. And then you see that actually people in general, they tolerate much less risk. It's around 10 and 30%. Because actually, if they will really have problems, if infected, the urge to go out, it's of course really, it's much lower, as we can see here. Then this I will not really take long. I just want to say that then we tested the questionnaire with the main questions. Okay, so one of the questions were one of the variables were contamination risk, right? 5%, 10%, 50%, and so on. The other variable is the salary offered, sometimes full, sometimes half salary. We have the interaction between this. Another important question of our questionnaire was risk perception. And another important question was the household income, which defined the salary. So basically here we just took everything from our questionnaire, put in the same model, a generalized linear model, and then we check whether this makes sense or not and go in the direction that we hope so. And as we already saw for the behavior data, everything goes in the same direction. Actually, it does not explain much here. It's just to save the model, to know that the questionnaire works. So then to start trying to understand the demographics, the first thing we did was a huge correlation matrix. So it was much huger than that. This was the main points I summarized here. Then we took all the demographics I showed you before, and here you have the K estimates. K estimates, just to remember again, the maximum tolerated risk of getting infected. And then we see, as expected, risk perception is negatively correlated. So if I think that I will be ill, of course I tolerate less risk. But interesting, we found that household income has a positive effect. So as higher my income, higher the risk I tolerate. We also found an interesting fact for risk group, of course. So if I'm part of the risk group, I of course don't tolerate much risk. I don't want to go out, right? But then we took this matrix, because this matrix is not, it's only exploratory, it cannot tell us a lot. But we took this matrix, and then based on this matrix, we construct, or we build this path analysis, structural equation modeling, because here we could really understand all the possible direct and indirect effects of each variable in the tolerated risk of contamination. So the starting point of leaving or staying home, right? And here I will summarize. Of course, we found interesting. We found that health professionals, as we can see here, it's only important for the half salary, but not for the full salary. We found that flu-like symptoms has a negative effect on this amount of tolerated risk, as well as risk group. We found an interesting effect for sex. I will go through this in the next slide a bit more depth. Age has a negative effect as expected. So as older I am, less risk I tolerate. But you can also see that age has an important effect or covariance with risk group, of course. As higher my age, maybe I'm part of the risk group. Age also has an important effect with income, for example, because of course, if I am older, it's higher the chance I have a job, so I have money, and so this was one of our main findings here. But then we were not that happy yet, because we thought, okay, this is cool, but let's try to predict some behavior. This is the fun, right, of our job. So then we thought, okay, let's try to see again these plots, and now let's try to understand who are those people. And then we thought, look, these guys here, they seems to be extremely risk aversive, because look, I'm offering this guy the best salary offer I have, and this guy said no. Even with the best salary offer, I will stay home, doesn't matter what. So he's really risk aversive. This guy here, otherwise, is extreme risk taking, right? Because look, I'm giving you only half of your salary, and you are going out anyways for the highest risk ever. So why, right? So these two are the two main groups, or the most important groups that we can find in our sample. And we try to understand who are these guys. So first, we track them on the data, and then we just compare the groups. And as you can see, the groups differ in a lot of stuff. I will not go through this because I have a better slide for that. But they are quite different. This is what I want to show, basically. But then we thought, okay, let's put all these variables together. Let's put all these demographic and COVID-related variables, let's put all together, and let's try to do logistic regression, right? Let's try to figure out what predict being actually risk-taking or risk-aversive. And then we did like a stepwise model, and then we found this interesting effect. For example, risk perception, of course, has a negative effect. So as much risk I perceive, less chance to be one of those extreme risk-taking guys, right? But then we found that, look, as higher my salary is, higher the chance to be one of the extreme risk-taking group. So it was the opposite of what people were saying in Brazil. People were saying in Brazil that, look, if you struggle to get money, you will go out, doesn't matter what. What we are seeing here is, no, if you have a lot of money, you're going out, doesn't matter what. Then, again, financial health confirmed this finding, because maybe I can have a lot of money, but it doesn't matter if I have a lot of problems to solve, a lot of things to pay. In the end, I have nothing. But so financial health is exactly this balance, showing that, okay, if I have a really, really bad financial health, I will not be the risk-taking group. Then we found this interesting effect for age. Here we see this arrow shape here, and we see that the highest effect was for 36 to 45 years old. Of course, people that are working, and then we have no effect for people with more than 56 years old here. Then we also found, actually, it was no significant effect for undergraduate, but we have then an effect for graduate, a negative effect for graduate people. So seems that as higher my educational level, less chance to be part of the risk-taking group. And then we found that unemployment, that actually is an interesting finding, because look, who is actually unemployed has less chance to be part of the risk-taking group. Of course, maybe the guy is not working, so why he should go out, right, to get any salary. And COVID contact, so the amount of contact this person believe, it's predictive factor for being a risk-taking group. This sounds a bit weird, but of course, imagine that if I'm going out every time, at least I have an idea that my contact with the virus is bigger than if I would stay at home. So this explains this. Okay, and to be part of the risk aversion group. Well, to be part of the risk aversion group, we also have like some interesting patterns here. Of course, risk perception is one of the most important ones, because if I think that nothing will happen with me, doesn't matter. I can have 100% risk of contamination. I don't care. I will not get ill, right? Sorry. Yes, it's right what I said, but it's in the opposite. Not here. It was right for the other group, not for this one. As higher my risk perception, more chance I will be from the risk aversion group, right? Because if I think that I'm gonna die, of course I don't want to go out. That was the example. Then we have the income range. Income range again. It's the effect is quite interesting. I mean, I cannot compare those effects, but we see that there's kind of a C shape here. So we have the higher effects for the upper low class and the upper high class. These are the guys that are actually more likely will be part of the risk aversion group. But actually, the guy who is for sure not being part of the risk aversion group is the guy in the middle class. This guy has a very, very low chance of being in this group. Financial health, again, it's important. And then we have this effect growing systematically here for age, right? So as younger I am, less chance of being part of the extreme risk aversion group. As older I am, of course, more chance. But here we found an effect for being a woman, meaning that women in general tend to be more risk aversive, not completely novelty here. And again, unemployment seems to be important. Anyways, this can give us a clue about who is the person that might be in one of those groups, but we are still not that happy. And then we run this conditional inference tree models. The conditional inference tree models will take all this data and we'll try to track, doing a lot of regressions and of course correcting for it. So these regressions are corrected for alpha errors, but trying to understand, okay, who is the person that really, this is the highest chance of being part of this group or not. And then what we found here, I can guide you here, is that participants who tolerate more than 65% risk of contamination to get the full salary, meaning that to get the full salary, they tolerate this amount of risk. The participants who are older than 25 years old, and the participants that actually has a really good financial health. So financial health goes to 0 to 100. Okay, sorry, I forgot to tell you before. So 60 means plus that, it's better than the average, right? So it's really good financial health. This guy has an 86% chance of being a risk-taking participant in our study. So the guy that's always going to leave home. So, and this model had an accuracy of 90% to predict in the other sample. And then we did the same, but then to track the risk aversive guy. And then what we found here is that, okay, the risk aversive guy is the guy that say, look, for half a salary, I do not tolerate any kind of risk of contamination. I'm not going out. It doesn't matter, the risk could be 1%. I'm not going out to half of a salary. So no way. This guy has less than 45 years old, and he has a really, okay, it's not the worst financial health, but it's really not a good financial health. This guy here has 77% chance of being the risk aversive guy in our study. And the accuracy of this model, it's around 92%. So these were my main findings to share with you. And of course, this study, as all studies, has many limitations. And here really just a few, just say some of them. It's online survey, as I told you. So of course there are a lot of methodological bias. I don't know how people actually answer this. Maybe they have someone else. Maybe they did together with someone. Maybe they were just not paying attention. They are just watching TV, whatever. And another limitation is that we have like almost 80% of women. So of course cannot be generalized to the entire population in Brazil. Additionally, Brazil, as you all know, it's a huge country. And although, everybody has stereotypes about all the countries in the world, we cannot generalize people from south to the north, at least to the west. So culturally are really different, especially in terms of political and positioning. So this not to be generalized as well. Again, another limitation is the data. The day we collected the data. So of course it was the beginning of the pandemic. I mean, not the beginning, the middle, let's say, right at the beginning, April, right? So in Brazil, it started getting really bad in February, March. So it was quite the beginning. Another limitation is that we cannot generalize inside of Brazil, within Brazil, neither with other countries, because of course, what is true in Brazil for sure is not true in Portugal, for sure is not true in USA, and so on and so on. And we, although we had a lot of participants, we cannot ask them a lot of stuff because it's online and people get tired and we don't want to lose the participant. So we don't know actually how many participants were able to do home office, or if they have internet connections, or if they have any other necessities which might change their behavior. So there are many data, of course, we cannot know. But I think that the take-home message is that, at least in Brazil, in this context, the decision to stay or not stay home, or to attend to social distancing seems to be dependent on risk perception and financial factors, mostly. Of course, there are many stuff that I show you, as age, for example, but mostly risk perception and financial factors. And the idea that people who are struggling, as I told you, struggling for money, would be the people that would not be able to go out, kind of is not sustained in our data. Our data show that actually people that are going out are people that have work indeed, and or has to work at least, and not only has to work but has enough money, and has a good financial health, Yeah, this is what I exactly just told you, and what we intend with this paper is not like point the finger, and say, look, you are the guy going out, and look, you are the guy staying home. Of course not. I mean, there's a bit of that, but the real reason behind is to say, okay, maybe it doesn't matter to try to do to start like a campaign, health campaign, and a lot of advertisement and publicity saying, look, the risk of contamination is pretty high and you will die. Maybe this is not the point. Maybe you should try to approach these people in another way. If you really want to change the behavior of someone, or to improve this healthy health measures like social distance, we need to know with whom we are talking, and then we can guide, of course, our strategies for this target people specifically. I hope I could send you the message. There's a long time that I'm not giving any talk, especially in English, so I'm sorry for this. but I hope you got at least the most important from that. And obviously, if you have any question or comment, suggestion, critics as well, I'm really good on critics, please let me know. And that's it. Thank you very, very much.
Thank you very much, Bruno. I think we have a space for a few questions. Someone online? Lauren, do we have one? Do we have something? Or Rodrigo? Or in the room? Someone else in the room? Besides Alejandro and me and Lauren? Some questions? No one? Because for me, it was really interesting. I mean, the card algorithm, or in Spanish, algoritmo card, it was so cool, to understand these two groups, risk aversion and risk taking, considering the financial health. And well, it was so interesting. Because I was thinking about how all this decision-making theory help us to understand the behavior in these conditions. I don't prepare exactly my question, because just I'm thinking about the card algorithm, to identify more precisely these two groups. And it was surprising for me that the perception of considering that you have health financial to, take care of you if you are contaminated. I mean, it's like, oh yeah, it could be, there is a risk, but I have the money to the treatment. So and this perception, like I'm safe, so I can be out, and I have the money. Exactly right. I have the money to be out, and the money to be safe with physicians, because I can pay. So this is interesting, right?
Yes, it's a pity that some things we only realize after we finish the data collection. So yes, this is for sure. And we discussed this in the paper. This is for sure one of the main points. We know that countries like ours, right? We know that money matters. We know that money matters if you have access to a good health hospital, good facilities, good health facilities, right? So yes, it's possible that people that have money just think, okay, doesn't matter, if I get anything, I go to the best hospital and I will solve this issue. And one thing that we really thought that could be interesting, I don't know how it's there. Please let me know, because I don't know if it's something only in Brazil, but I don't think so. Thinking about US and Europe at least, there's a really important political debate here. I would like to know how people see themselves in terms of right and left wings and decisions. This is a question that we really had a lot of discussion about including or not. And then in the end, I thought, okay, not include, not create like a chaos. But I would think that, for example, people that support a lot of our president would be the persons that are always going out. And then people that hate him would be people that would never go out. This would be also interesting, to know or to understand, not to point the finger, but I think it's interesting to understand, look, even a super important decision about your own health, it's guided by how do you feel connected to ideas or lifestyles or beliefs about the world, and so on and so on. So this was also a thing that was unfortunately missing in our data.
That's so interesting because we have a special issue here in Mexico with our president. It's almost the same. The president he doesn't want to use the mask. I mean, I can remember exactly the word. I mean, he doesn't want to use it. So this is so interesting because probably it's related with the risk taking. I mean, in the general population, because we have many many cases about COVID here right now in Mexico. I was wondering now that if this is related with all these ideas that even with these political issues with our president, who is mentioning this, that like it's okay not to use it. I don't want to use it. I don't want to use the mask, or I don't mitigation behaviors or the recommendation. So this is so interesting. It could be related. I don't know. And the financial health situation. Wow, so interesting. Thank you.
Yeah.
I guess I don't know. Question here. Oh.
Yeah. Mm. A matter of No, yeah. Actually, to be honest, it's a very interesting hypothesis. Actually, yeah. I have to be honest. I didn't thought about it, but yeah, like completely Nash equilibrium, right? Like it's a Nash equilibrium, right? As you said, if everybody goes out, it's bad. Everybody stay home, it's bad. Maybe you just have to balance this species somehow. Our species. Yeah, it's a very interesting way of looking at it. I have to be honest that when I was analyzing the data, I faced a problem in terms of how to really approach the behavior and how to really approach it, because I could not really go super deep in, like, for example, such kind of theories, which would be interesting for sure. And at the same time, try to keep as much as how can I say, publish it, attractive to be published. You know what I mean? Like, people would like to see, okay, but what is really guiding this? On the other hand, I totally agree with you, and this is something that I like to do, like to go back to data. I like to keep going on the data, even if it's already published. So I will try to figure out some algorithm in this regard, because I think it was a really good idea. If I don't know, yeah, exactly. Yeah, sure. Uh, Thank you very much. Thank you very much. A bit of everything. Okay, thank you very much.
Thank you, Bruno. We don't have more time for questions, but I'm gonna let you know more reflections about your presentation. Right now, just a brief announcement before continuing with the presentation of Marina Gross, who is online. Please do not forget that in order to obtain the certificate of attendance, you have to sign in and fill in the Google form that is posted on Twitter, Facebook, or YouTube. Un breve anuncio antes de continuar con la presentación de la doctora Marina Gross. Por favor, no olviden que para obtener el certificado de asistencia deben de registrarse y completar el formulario de Google que se encuentra publicado en Twitter, Facebook y en YouTube también. ¿Ok? Bruno, thank you so much. And welcome, Marina.
Bye.
Bye. What a pleasure to see you. Take care.
You too.
Hello, everyone. I really hope that you're enjoying the Congress as much as we do. Thank you very much, Bruno, for the super exciting talk. Before starting the next with the next speaker, I would like to ask you to access the links that we put on Twitter, YouTube, or Facebook to fill out the survey of Dr. Bruno Sklu's talk. I can see that there are some questions in YouTube. Don't worry, I'm gonna send again all the different links for the different presentations. I'm going to do it like after I present Dr. Marina, I will do it. So don't worry about that, okay? Now it's time to continue with our talks. It's a pleasure for me to introduce to you our next speaker. She's a super cool researcher. It's her PhD candidate, Marina Gross. For those who are not unfamiliar with her work, Marina graduated with honors from the psychology program at the University of Oregon. She has a master's in cognitive psychology, brain behavior, and cognition track from Washington's University in St. Louis. During her professional career, she had won several fellowships and grants from different universities and institutions. Most recently, the Graduate Research Fellowship from the National Science Foundation. Marina has also been awarded several times for different foundations and universities, including the University of Oregon and the Washington University in St. Louis. Currently, she's a doctoral student at Ian Dobbin's Memory and Decision Making Lab at Washington University in St. Louis, and her main interest in research includes using pupillometry and behavioral measurements. Marina investigates memory processes and how they relate to our conceptualization of attention or cognitive load, and how can we use these pupil dilations to observe how we learn and forget information. Today, she's gonna delight us with her talk entitled, "Look at Me in the Eye, What do changes in pupil dilation during learning tell us about memory?" Now, I will do Marina's presentation for our Spanish speakers. Espero que estén disfrutando muchísimo del Congreso, tanto como nosotros. Muchísimas gracias, Bruno, por la charla tan interesante. Antes de iniciar, me gustaría pedirles que accedan a los enlaces que colocamos en Twitter, YouTube o Facebook para llenar las encuestas de las pláticas. Tienen algunas dudas en YouTube, no se preocupen, yo voy a poner todos los enlaces de todas las pláticas de nuevo para que las puedan llenar y con esto puedan obtener su constancia. Ahora sí es el momento de continuar con las conferencias. Es un placer para mí presentarles a nuestra próxima ponente, la doctoranda Marina Gross. Para aquellos que no están familiarizados con Marina, ella es graduada con honores del programa de psicología por la Universidad de Oregon. Tiene una maestría en psicología cognitiva, cerebro, comportamiento y cognición por la Universidad de Washington en San Luis. Durante su carrera profesional, y créanme, ha ganado muchísimas becas, subvenciones de diferentes universidades e instituciones. La más reciente es la beca de investigación para graduados del National Science Foundation, que es una de las más importantes en Estados Unidos. Marina también ha sido premiada varias veces por diferentes fundaciones y universidades, incluida la Universidad de Oregon y la Universidad de Washington en San Luis. Y actualmente es estudiante de doctorado en el Laboratorio de Toma de Decisiones y Memoria de Ian Dobbin de la Universidad de Washington en San Luis. Su principal interés en investigación incluye el uso de pupilometría y medidas conductuales para investigar algunos procesos relacionados con la memoria y cómo se relacionan estos mismos con la carga cognitiva. Marina utiliza las dilataciones pupilares para observar cómo aprendemos y cómo olvidamos cierto tipo de información. Justo hoy nos deleitará con una charla titulada Mírame a los ojos, cuáles son los cambios en la dilatación de la pupila durante el aprendizaje y qué nos dice de la memoria. Tan solo un recordatorio, Marina tendrá 45 minutos para presentar y luego tendremos 10 minutos para preguntas. Just as a reminder, Marina, you will have 45 minutes to present, and after that, we will have 10 minutes for questions. Without any further delays, please welcome Marina Gross.
Hi, everybody. Hola a todos. Hello. For everybody speaking all the languages all around the world, I'm really excited to be here. I'm going to share my screen. If you could just give me feedback that you can see my screen or that you can see my presenting slide.
We can see your screen.
Perfect.
Yeah, perfect. That's
great.
Perfect.
Thank you so much. So I am very excited to be here today. Thank you so much for asking me to share about my research. My camera is right here, but my slides are right here. So you're going to see a little bit of my side profile. Before I get started, I want to acknowledge that I and the Washington University reside in St. Louis here on the ancestral lands of the Kickapoo, Osage, and Miami people. And I am known for reminding people that colonization is an ongoing process, and it's happening right now all over the world. In the United States, for example, tribal nations are fighting right now against the forced removals from their lands at this very moment. And if you want to get involved and see how you can stop further colonization, you could, for example, go to ApacheStronghold.com. And if you want to learn more of whose land you reside on, either in the United States or Canada, you can go to nativeland.ca. So I'm doing my research on the ancestral lands, and it's very important for me to acknowledge that first. So I'm here today to talk to you about pupillometry. So pupillometry is the study of cognitive processes through the eyes. It's been a popular research tool since 1964, so it's been around for a really, really long time, and it has come a very long way since then, and really like almost 60 years. I'm going to show you some classic findings, things that are established, and then I'm going to tell you about a paper and some results that we have out. What you can see here in 64, Kahneman and Beebe were the first ones to measure pupil dilation during learning. What they did is they gave people numbers, strings of digits to remember, so hold on to these numbers. And as you can see here, the more numbers that people were asked to hold in memory, the bigger their pupil dilation became. So this is during learning right here. And then what you see here is that there's a short pause between learning or coding and retrieval, maximum pupil dilation is achieved. It's almost as if like people are rehearsing what is in their memory store. And what you can see is that as soon as people are starting to recall these digits, those digits are the pupil dilation starts to diminish. So it's an increase and then a decrease. In a follow-up study, so we're talking about this as like an amount of information people are holding on to. In a follow-up study, they looked at the transformation. If transformation may be changing the way that pupil dilations are indicating what's going on. And here they either had people, again, remember 4 digits, they had them remember some words, or they were asked to do transformation. And here really they were asked to do some math. And as you can see, as the task gets harder, again, pupillometry, if the pupil was larger in doing encoding. At that time, people were talking about this in an effort, difficulty kind of load way. And that was the language in the 60s. So now talking about the current state of pupillometry, I'm going to talk first about the memory retrieval, so what happens at test, because those results are pretty well established. And then I'm going to talk about memory encoding, which is my specialty. So I'll start with memory retrieval. So pupil dilations at test. So after people have learned, and now I'm asking you to recall the information. In one of the studies, a very well-known study by Vo et al., they talked about the pupil new old effect. And what they did is they measured pupillometry at test. And what you can see in their results here is that old words, let's ignore what those are for now, that these old words solicit larger pupil dilation at test, which means that when people are recognizing these words, the pupil is larger than when they did not recognize the words or when the words were new. They also did some with neutral and negative and like valence of the items, so there was some emotionality in it, but let's put that aside for now, or we can talk about it some more later if you'd like. So here, old new effect, older items, larger pupil, new items, smaller pupil at test. Papesh and Goldinger had brought forth some evidence that showed that dilations at test are strongest when the memory signal is also strong. So what you see here is that this is the average peak diameter, and as participants became more confident that they recognized an item correctly, the larger their pupil dilation was. So there's not quite a linear increase here, so it's not unproblematic, but we can see the strongest memories were judged to be more confident, were also related to the largest pupil dilation during test. Lastly, I want to talk about a paper out of our lab that my advisor had published just after I got here to graduate school. And that is a paper where people were given recognition cues. They were told this next item is likely going to be old or new, and they were investigating if maybe surprise can be measured with a pupil. And this is really detecting something unexpected in our environment. So what we see here is that there's no difference between a hit, so this is correctly recognizing an item, and a correct rejection, correctly saying this is a new item I've never seen. These overlap. really closely here, and this is the correct responses, and this is our pupil dilation. So for old cues, like this next item is likely going to be old, people respond old, great. When they get a new cue, however, when they're expecting a new item, when they then recognize an item, there's a huge pupil dilation, and it's largely different than the one for the correct rejections. And they call this kind of an unexpected surprise signal that's happening. And this is likely because it's, again, unexpected recognition. We refer to this as probably an orienting response, that something unexpected is happening in the environment. Evolutionarily, we need to pay attention. We need to figure out what's going on. This is really interesting because we've seen this now in a lot of our data sets. This also holds in my own data sets that I have, and it's something that we think about writing up next. So when we talk about pupil dilation during memory retrieval, that's decently well established. It seems like when you correctly recognize something that your pupils are larger, it is very it's pretty much a done deal if you want to put it that way. Looking to memory encoding, though, that's a very different conversation. So when we look at memory encoding, it's kind of all over the place, and colloquially, I would refer to this as a hot mess. Like, we don't actually know really well what's going on. So here's a paper from Ariel and Castell where they assigned different kinds of values to the items, so low, medium, and high value, as in like the high value items, you get more points if you remember them later on. And what you can see here, these are the pupil dilations, that the largest pupil is happening during the highest value items, and the highest value items, of course, are also the ones that are recalled recognized at a better rate. So here, what it's seeming to say that this is kind of like, maybe there's a distinctiveness going on, it's an elaboration, you would put more work into items that are more important to you. In a paper that myself, I was a co-author on with my previous advisor at University of Oregon, Nash Unsworth, and his graduate student, Ashley Miller. Here, what you can see here, again, these are pupil dilations always on the y-axis. And what you see here is that this is typical, and these are high working memory capacity people. So these are people that have really good study strategies. Their pupils increase as they go on learning more items. Again, giving support for this elaboration and distinctiveness kind of explanation of the pupil. Lastly, we have evidence from Neighbor et al. In 2013 that had people look at photos, natural images of like trees and parks and such. And what you can see here is that people who later correctly recognized items, here the pupil actually constricted. So here it was smaller. So here they are saying that it's an efficiency of encoding signal, that if the pupil is smaller during encoding, that will lead to better recognition later on. And so here they're saying like, oh yeah, of course, this makes sense because it's efficient. Kafkas and Montaldi showed the same exact findings, also pointing to efficacy of encoding. And what you see here is, again, peak pupil, and these are the memory strings that people show on. That's what people later rate these items on. Again, this is encoding dilation, so during study. And the items that people later rated as really remembered rather than familiar or new, you can see that there is the small pupil dilations for these really strong memories. So really what's going on? So we have, and then in addition, sometimes I'm not going to show these results. Sometimes we have just null results where there's no relationship between the pupil and encoding whatsoever. So right now we have elaboration, efficiency, cognitive load, like what does it mean? So it's really inconclusive of what is going on right now when it comes to pupil dilation during learning. There are two main interpretations that are really directly in conflict with each other, and those are the ones that are most interesting to me. One of them is elaboration, where we say more load, so more cognitive load coupled to larger dilation will lead to better memory, versus this efficiency argument that says less load, so smaller pupil dilation will lead to better memory. And so, of course, you can see that both of these cannot really happening. They can be true at the same time. It has to be one or the other. And the problem is that a lot of these studies I showed you don't use an encoding task. So participants just sit there. They don't have to do anything. They just sit in front of the computer. And a lot of people call this cognitive load. And that is a very ill-defined term. And this is something that in my discipline, we have done a little bit bad practice by and use it for anything and everything. As soon as somebody says, oh, there's a pupil dilation, someone will call it cognitive load. So what does that mean now? Like, what do you do? What do we do, right? So what does a pupil actually track? We do know that the pupil is a physiological marker of arousal. So if I see something that is pleasant, if I see someone I recognize, if I see somebody that I find attractive, right, the pupil will dilate. It is also an indicator of processing load, but what processing load means has been a little bit overlooked and forgotten. And I'm going to show you what Kahneman, who originally came up with this theory, has written in 1973, so a really long time ago. So he refers to this as the momentary effort that a task demands must be distinguished from the total amount of work that is required to complete the task. And this conception of mental work suggests that time pressure must be an important determinant of effort. So it's not just the amount of information, it's not just how hard I'm trying to study this, but it's also how much time do I have to do this task. So it's the amount of work per unit of time. In this unit of time, this time pressure component of dilations during learning has been really largely overlooked. And so, of course, as a scientist, we go out and try to test these two accounts. And so what I did was pit these two together against each other. So we have this elaboration, distinctiveness of information that would hold that if you elaborate more, there would be more load, there would be larger dilations that would lead to better subsequent memory, versus the time pressure part, or maybe in addition, not versus, but in addition, the time pressure or processing urgency that says, if there is more time pressure, you will feel more arousal that should lead to larger dilation, but poorer subsequent memory. So these two can happen at the same time, but what I thought going into this, that one of them might win over the other a little bit more. So we have the same results, but two different interpretations. Now I'm going to show you some of the experimental design that we went into. This paper is already published, so I can either send it to you or it's easily found. And if you can't find it, I'm happy to send it. So what I did here, excuse me, I have a little bit of a cold, so you can hear that. What I did is manipulate the degree of elaboration and processing urgency in a 2x2 design. So what we used was a levels of processing manipulation, so shallow versus deep encoding. We know that deep encoding leads to better memory. So doing a task like a pleasantness rating versus can you count these letters? And then I influenced the time pressure. So I told participants either you have to do this really fast or take as much time as you need. Excuse me. Take as much time as you need. Importantly, even when people were speeded, when I told them you have to do this really fast, there was no deadline. They did not know this. We trained them to be fast, but actually during the task, there was no deadline to respond. But as you will later see, this manipulation was very successful and people were really a lot faster. And so there's 4 different conditions: the deep and shallow, the speeded and unspeeded. This is a pleasantness task that I just talked about. And then there is a letters task where we ask people to actually say if the first and last letter are in alphabetical order, which is a pretty difficult task, actually. And I'll talk about that a little bit later. When we look at an encoding trial, this is what would happen on the screen. You would have a baseline for 2,000 milliseconds. That baseline gets cut in half. So 1,000 of that becomes the previous trial dilation, and then the second 1,000 milliseconds becomes the pre-trial dilation. Participants then see a cue for 750 milliseconds. This is a task. The pleasantness, tell me how pleasant this word is. You have to do it fast. You get the probe. The probe is on the screen for 4,000 milliseconds, regardless of how fast they respond, so that there's time to encode. And then we have a drift track manipulation where people have to look in the middle of the screen to make sure that the pupil is being tracked accurately. We had 34 people. We obviously tested a lot more, but with failure in data, you lose a couple of people. I think we tested almost like 50 people or something like that. But the undergraduates at Washington University did not always want to stay for an hour and a half in my lab. So sometimes they just left. All right, so returning our attention to the results. So, and again, we had with the thing we're mainly testing here is like elaboration, time pressure. We know from the levels of processing manipulation that's happening here that leads to better memory. That's well established. So let's look at overall accuracy in these different conditions. So overall accuracy, you can see that the accuracy is largely the same in the speeded and unspeeded conditions. I'm only showing you that because, like, if you look at that, there seems to be not a huge kind of difference. Now, what of course is important is to look at the subcells, right? I told you there's 4 different conditions. So what I'm going to show you here is the accuracy broken down by the speeded, unspeeded conditions, and then the deep processing and the shallow processing. And this is the mean subsequent hit rate, so correct rejections minus false alarms, and the box plots that I'm going to show you show the median in the inner quartile range. And so what you're seeing here in these conditions is that the speeded task, I'm sorry, let me look at this. The deep task is just as well remembered as in this unspeeded condition as it is in the speeded condition. So the time pressure did not influence the subsequent recognition behavior. So people remembered it just as well. This makes sense because each word was on the screen for 4,000 milliseconds regardless. And then obviously what you see here is that the shallow items are less remembered than the deep items. And we know this because that is something that is well established. And we knew this was happening. So this is our manipulation check. Now looking at reaction times, and this will of course be important because we're looking at time pressure here. So looking at the reaction times, what you see is that in unspeeded conditions, people were a lot slower than they were in the speeded conditions, which is great. They actually did the task that we told them to do. And you see that the shallow task actually took a little bit longer than the deep task. So the blue here, that is the shallow task. That led to that had a little bit of longer reaction times because that task was actually difficult. Some people might say, well, but we need that is a confounding, I'm sorry about that, a confounding variable, but it really is not because there's a lot of data that shows the length of time an item is on screen does not influence the levels of processing, but it's actually a really cool thing that happened here because we're looking at time pressure and it gave us another way of analyzing the data, and I'll talk a lot about that. So as an interim summary, just what we found behaviorally is that the deeply encoded items are better recognized than the shallow items. That is not surprising. The speeding resulted in faster response times, but there was no memory differences when compared to the unspeeded trial. So there's the same accuracy when it comes to recognition, but there is substantial reaction time differences. And when you look at the shallow trials, they were responded to slower than the deep trials. So that's kind of that's the interim summary here. So of course, we're all here to talk about the pupil. So let's do that. Let's look at some pupil data. So what I'll show you here is the percent dilation response on the left-hand side. This is that is a change from baseline. And then you see when the cue was onset and when the probe was onset. So this was the cue, what is the task? And then 4,000 milliseconds is when the item is on screen. And then you'll also see this blue bar underneath. And that is really the family-wise corrected p-val, so the probability values, p-values, that shows you during these times, these results were significantly different. We did this by bootstrapping a bunch and making sure this is a very conservative estimate, which is great for publication because people actually thought we were a little bit too conservative because we had to have, when we bootstrap, we had to have at least 10 iterations where something came out significant in order to actually count it, which is a pretty high bar. So the first thing I want to look at is the pupil in the time pressure that we talked about. So the speeded versus the unspeeding conditions. What does that look like in the pupil? What happens? So what you can see here, I'm sorry, my cat is joining us. And what you can see here is that in the speeded conditions, the pupil is substantially larger than in the unspeeded conditions. So this purple bar right here is the speeding, and the green here is the unspeeded. And that is pretty reliable throughout. That is happening almost the entire time. So the pupil is larger when people are sped. And when they have to do something really fast, more work over a short amount of time, which makes sense in a Kahneman interpretation. Now, what's important here is that the accuracy that I showed you earlier, these two don't differ, right? So the accuracy in the speeded and the unspeeded condition are the same, which means that the pupil is not tracking any kind of encoding differences here, which is very sad because that is my corner of the universe. But the data are what the data are. I was hoping that they would be predictive, but you can see right here that the timing is actually what is reflected here in the dilation rather than accuracy because these are the same. So we set out and we're trying to see like there's time pressure, but we also had this levels of processing manipulation, right? So we wanted to see, excuse me, is the pupil picking up on levels of processing results? excuse me, I was distracted by my cat. So what you see here, again, is that this is the LOP condition. This is the shallow and the deep. What you see here is the pupil is larger during the shallow items. So when you think back earlier, someone was saying that, elaboration is what the pupil picks up. The more people put work into it, the larger the pupil becomes. Here, you can see that that's not true because the deep task is recalled. Items are recalled much better than the shallow task, right? So this is actually not elaboration. This has got to be something else. So when you look at, so now we wanted to dig a little bit deeper and see how could we distinguish the time pressure from the LOP effect, so to speak. What we did was compare the slowest shallow task, so the one where they took the most time, to the quickest deep task. So what we see here is like as more time passes, right, more time pressure accrues, and that should be reflected in a larger dilation response. And that should actually be added in the slowest shallow task because that task was already slower, but to begin with. So what do we find? And so we're asking, like, can we amplify and diminish LOP effects? And to force it, like, yes, we can. So here again, this is already what I showed you. This is what we thought was an LOP effect, right? That the shallow task would be associated with larger pupil dilations. And this would support the second account, the efficiency account, saying that, good learning happens when the pupil is smaller. If you didn't look deeper, that is the paper you would be writing. This is it, we're putting it out the door. However, I told you that we wanted to look at time pressure, so we dissected the data and compared the slowest shallow task versus the quickest deep task, and then also the quickest shallow versus the slowest deep task. And so what you see here is that when people spend more time, the slowest shallow, this is where they use the most amount of time, versus the quickest deep task, you see a huge difference in pupil dilation. And in the wrong direction when it comes to elaboration. You see here that the more tasks they take, the bigger their pupil is because they need to finish this task. And the longer they go, the more pressure is there to finish the task and do it quickly. And so he is not speeded, so here is not it quickly. When we flip this and look at the quickest shallow, so here you see that the orange bar is actually on the bottom, so it's quicker. And you can see that this is not as far apart. These are very close together. In the slowest deep, which is the blue. So here, this slow deep, you have all the time in the world to make this decision. Is it pleasantness? If it was elaboration, then you would see a very big pupil dilation here, but you don't. These are different, but barely so. So this, of course, then cannot be a real effect. If I can play around with this and can break it down like that, then this cannot be real. And so what people refer to as an LOP in the pupil effect is actually a time pressure effect. And there's nobody who has necessarily said it's an LOP effect. There were some papers that say it must be, but here we see very clearly that that can't be true. So after being crushed, said now we're embracing that's all mostly time pressure. I wanted to make sure that we can see this in all different conditions. So it's not just when I do the big comparison, but then it should be visible in every single subcondition. So what we decided to do is break down all of the different conditions, so the 4 encoding conditions, and look at them with the fastest, the middle, and the slowest third of reaction times. So give me the fastest, the middle, and the slowest. And what does the pupil do, right? If it's all time, then what we should see is like the slowest one should come out on top because people took the most amount of time. And if that isn't true in all of the conditions, then that is maybe not time pressure, something else may be going on. So looking at, I'm going to look at the speeded shallow first. I'm going to show you one of them, and I'm going to show you all 4 afterwards. Here you can see, so I put this down so you can kind of see, spinny wheel Mac, that's not good. You can see which condition this is. So you see here, the slowest, the red, has the largest pupil dilation. The middle is in the middle, and the fastest third of reaction times is on the bottom. The faster people respond, the smaller the pupil is. The longer people take, the more time pressure builds up, and the more the pupil dilates. And so what we have here is like a Q level and a decision level kind of effect, right? So you're getting this Q, you have to do this fast, and now you have to make this decision. And as you run out of time, more pressure builds up. And the story holds true in every single one of these conditions to a different degree. So what you see here, is that this effect, this red line, the slowest third of reaction times, is the same in every single conditions. It's the least dramatic in the unspeeded deep, but you can see that it's reliable in every single condition. And I believe that this figure is what sold the paper, because it's very surprising to see it this way, because this time effect sits in every single pupil paper that is out there, in every single one. And so a lot of people went back and have looked at their own data and was like, oh gosh, we have time effects in our pupil. So we also have the main question, and one of the main questions is also, what about subsequent memory, right? Can I predict successful memory while you are learning? If I look at your pupils while you are learning, can I predict what you will remember down the road and what you will forget? And that is really the sexy question, really. I think that's the question that's why the NSF funded my research, because it would be really great if we were able to observe students learning and can intervene when we can tell that they're not learning well. So when we look at the subsequent memory effect, so dilation during encoding, what we see here is dilation is again linked to time pressure. So here we're looking at, again, dilation. These are the items that are subsequently missed. So these are items that are correct, but were not recognized. And then the items that were correctly recognized, so we call that a hit. And you can see here that the misses sit on top of the hits. So here you would say that correctly identified items would be smaller, again, in dilation. You would think like, oh, okay, so it's more efficient encoding, that's why. But if we think about it in a sense of work, these misses, the items that are not recognized, actually would elicit more work. So that can't be the explanation. So what we look at here, then when you compare to the encoding RTs, you again see for the misses, they also took more time to actually make their encoding decision. So this is, again, that's a time effect that's sitting right here in these data. And this is overall. And so I'm going to now show you that broken down again by the 4 conditions, because I do think it's important to look at it all the way. So what you see here is the speeded condition. Again, we have this unspeeded condition. And what you see is that the shallow sits on top of the deep task. And so, again, it's the opposite of what we would expect if levels of processing is, because it is associated with more elaboration, all these kinds of things. We have studies where it shows that people rehearse more, they use different strategies, it leads to better memory outcomes. But what we see here is that it is associated with smaller pupil. Remembering back the accuracy results that I had shown you, you can see that the pupil unfortunately does not track encoding, right? Because you see these huge differences, behavioral differences in accuracy in this unspeeded condition, but you don't see the difference in the pupil. So when you account for time, there's really, there's not a lot of excitement here to be shown. So like this original idea that we could maybe track memories as they are being created currently, I would say that we can't do that. So what did we learn overall? I want to bring this home to kind of sum it up for us. So what did we learn so far? And what does the pupil say? What does it mean? So what we know is that behaviorally, what we see from this study is that deeply encoded items are better recognized than shallow items. Speeding resulted in faster response times, but there's no memory differences between the two compared to this unspeeded condition. And the shallow trials were responded to slower than the deep trials. And this main question that I asked, what do changes in pupil dilation during learning tell us about memory? From my data, what we take is that deep items are associated with smaller pupil dilations than shallow items. We saw that reliably. Speeded trials, however, are associated with larger dilations, and this difference is even pronounced in the shallow condition because the shallow condition took more time. So it's kind of a time pressure on a time pressure kind of a situation. We see that larger dilations during encoding actually predict subsequent forgetting. And again, breaking down the response time by fastest, middle, and the slowest response time, what we see is that the slowest third is always associated with the largest dilation. So what does this mean for us? It means that the pupil is largely insensitive to the depth or the quality of processing. So we cannot currently, in my professional opinion, assess the quality of material as it's being encoded with the pupil. Instead, what it looks like is that the pupil is incredibly sensitive to the time pressure doing judgments, because you could take all of my data and slice them all kinds of way, and time always comes out on top. This really supports Kahneman's original emphasis on time pressure in the conceptualization of cognitive load. So it's not just amount and what kind of elaboration you are doing or what kind of mental process, but it's also the amount of work you are doing per unit of time. So time is a really important factor. And really, when relating pupil dilations to cognitive processes, we need to control for these time pressure effects, because otherwise the time pressure effects are really confounding what you are actually studying or what we are studying, right? There are, of course, a couple of limitations that people pointed out to the study. One of them is that speeding didn't influence subsequent recognition performance. That isn't actually, to us, that wasn't actually, it wasn't a downside. It was surprising, but it doesn't really actually matter. Because what we did is that we equated the length of encoding across both conditions. So people could have continued to elaborate or continue to do whatever they needed to do because the item stayed on the screen. We have, if COVID had not happened, we had planned to do this in the self-paced paradigm to kind of see what happens there. And also we wanted to look at individual differences and aging differences. Like, are some people better at this? Are some people good at measuring how much time they have used? Do they track their own time better than some people? And of course, are there differences across aging? Because that would be a really interesting thing to look into, of course, having one of the leading Alzheimer research centers in the world, quite frankly, right here in St. Louis. And with that, I want to just name my funding sources because I'm required to do so. One is the NSF. One is a graduate research grant that was awarded to me to pay my participants. And then our eye tracker was paid for by the McDonnell Center for Systems Neuroscience. And with that, I gained up a lot of time. And I'm really happy to take some questions that I would love to answer.
Perfect, Maria. Thank you so much for your talk. It's honestly, from my point of view, it's an extraordinary talk. I have never had the honor to actually saw your presentation, but it's very spectacular. I think, like, honestly, since the beginning, I was like very thrilled about what was happening, you know, like, and then you change all the story, and it was super good. So I really appreciate. I had a lot of fun, and I learned a lot about your research. If you don't mind, can you stop presenting so you we can see you, and so people can actually ask you questions. For all the participants that are on YouTube or Facebook or on the GECC platform, please. Feel free to ask questions to Marina, and if you don't have any, or you don't want it to tell the question in English, we can translate it for you. In the meantime, I really want to be, I don't know, I think I was expecting from your talk that I was very amazed when you said the dilation during coding didn't actually happen. And I don't know, it was very weird for me, like, because I don't know, when you started presenting the deep and the time, you know, like you put it in the table, like time, speed, the difficulty of the task, and all these different variables. I was trying to think about spatial navigation tasks because that's kind of the thing that I do, right? And when you're talking about encoding and memory encoding, I start thinking like, well, yeah, time it's very valuable for, like, from a biological point of view, is very valuable for an animal, right? But in probably, have you ever tried in general? Have you ever tried your task in a more natural setting for saying?
Mm-hmm. When you don't speed participants? Exactly. Mm-hmm. Yeah, so we have done that in our lab. And what you see there is that they actually didn't collect data doing encoding, I just realized. So they did not. I, however, have done pupillometry since I was in undergrad. And there we would have said, and I have a paper out there that links larger dilation to better subsequent memory. I have that in writing in a journal. And the thing is that, like, of course, you have to be mindful is that we can't really cross-compare across experiments. However, what is really important is that I had control over what participants were doing, or to the most that is possible. Where the papers I talked about earlier, there was no encoding task, so we actually don't know what participants are doing, right? So I come from a working memory lab. That's where I got my undergraduate. That's where I did my undergraduate thesis. And we know that people mind wander. People think about getting out of the experiment. People think about food. Think of people about how cold it is, how much they don't want to be there. And so you just don't know what they're doing when they're sitting in front of an eye tracker. And my undergraduate advisor, Nash Unsworth, he has some papers out there looking at baseline dilations. And even those are all over the place, depending on what participants just staring at a screen. They're all over the place. So we actually don't really know what's going on until we control, or try to control as much as we can, what participants are doing with an encoding task. So really the excitement of this paper is really that there's levels of processing, there's an encoding task, and we have this time pressure that's happening.
Yeah, well, it's amazing work. Lauren or anyone else, do you have any other questions? I think Peter want to talk, right? Oh, okay.
Oh, I think he accidentally left the meeting.
Yeah, I think so.
He'll be right back. But Alejandro, you had said that you were also asking about like a search display, right? And like searching for something that you're looking for. There's in this paper that we published, we also talk about this processing urgency from a modeling perspective, because there's a paper in the visual, I think it's in neurophysics, I want to say. So it's a visual search paper actually by Boonstrap and Murphy that talks about processing urgency. And as you get closer to a decision deadline, that actually would predict that dilations would get larger. We weren't aware of this paper when we did this work. It's actually when I presented it and someone said, have you read this paper? Because this is what they're saying, but in a different world of pupillometry. It's like, oh my gosh, that's amazing. And that's basically what they would predict. Like if you have less time and as you get closer and closer to a decision deadline, you have to make a choice. And I don't know about you, but when I get closer to a deadline, I'm like, I have to leave. I don't know, this one. Like you just pick something because you have so much time pressure. And this is the innate thing that's happening. So yeah. That's
completely true.
Yeah.
Here, you have the word.
Yes, I went to hit my microphone button and I hung up on the conference.
I won't take it personal.
I had to scramble to get back. Do you know, that was a very nice talk. There's a lot I didn't know. I've heard it said, Marina, I don't know if it's true, that it sounds like there's too much noise to answer this question affirmatively, whether baseline pupil dilation is correlated with working memory or dynamic processing. Do you have any understanding of that?
I do a little bit, yeah. So I'm no longer doing that research all the time, but I know that my previous advisor, Nash Unsworth, they have just done a very big review of a bunch of baseline papers and actually looked at the relationship between baseline pupil dilation and fluid intelligence, memory capacity, and all those kinds of things.
I'm holding my breath. My pupils are very dilated now.
Yeah, it's like, oh, you're now aroused because it's interesting. So what they found is that there's actually it's a methodological difference. Sorry, also a second English speaker here. Sometimes I can't say words.
Never guess that.
Yeah, it's sometimes it's the relationship that is reported between baseline, so what people just looking at the screen, and their later performance or fluid intelligence. That is probably due to screen luminance, timing, and something else. So he goes deeper into this paper, but it's really interesting because there's another research group out of at Randy Engel's lab at Georgia Tech. And so that is where he actually got his PhD. And so they've been having this conversation. So they have been publishing papers back and forth about each other's data, which they all have. And they're actually working on it together, which is really cool. So it's very collegial. It's like, what is it? Like, when do we find these relationships and when do we not? And quite honestly, I was getting really uncomfortable for a while there with what the Engel group was putting out, because they were saying almost like it's deterministic. Like if your baseline is this, then I know what kind of learner you are. And I don't think that that's what we can do. And I think that goes a little bit almost into the, we don't want to go to that past, that dark past back and saying, oh, if I measure this about you, then you must be this. And so it's really great that they're actually coming and figuring out that that's not what's happening there. And there were a couple of correlations that still hold, but yeah, I'm happy to send that paper. It's a really great paper. And then Sukahara and Engel, they have since published a new paper saying like, oh yeah, this is what it is, and it might be the background of the screen. I'm
amazed that that's not been controlled regularly in this research.
Yeah, so like we have all been actually, so people who do this were like, we all need to use a standard.
Yeah.
So for example, I use a gray background, the same as Nash does, but in the Engel lab, they're using white or black.
Oh.
And so, of course, there's a luminance difference, and you wouldn't necessarily think that that would do anything because you're measuring a baseline. However, if you think about the pupil, there's a max, there's a ceiling and a floor effect. So depending on where you situate me, I have either farther to go or less to go, right? So it actually makes a lot of sense that that's what's happening. But yeah, they're really great papers together.
Cool, very cool. And it seems reasonable that you're using a gray background. It can go either way.
It's also easier to read. So like it's readability, accessible, those kinds of things. So yeah.
Very cool. Thank you so much.
Yeah.
Well, again, Marina, I think there are no more questions, if I'm not incorrect. But I really appreciate in behalf of everyone in the organizing committee for the time that you actually take for your presentation and for the great explanation that you made today. And I just want to tell you thank you. And it was an amazing presentation.
Thank you so much. I'm really glad to be here.
So we have a little announcement. Again, everyone remembers that you need to go to the link that I'm going to post on Facebook, Twitter, and YouTube, so you can fill in and get your certificate of attendance. Ahora vamos a continuar con otra plática. Por un momento vamos a pausar todo esto. Si quieren pueden ir. Ya mandé las invitaciones de los links para que contesten para que hagan la constancia rellenen el formulario de la plática de la doctora Marina y con eso puedan ganar su constancia. Vamos a detenernos un poquito para ahora dar presentación a Joel y bueno, vamos a continuar. Gracias, Marina. Thank you, Marina. That's it.
Marina, thank you so much for your time. We really enjoyed your presentation.
Thank you. This was really fun. I'm glad I got to talk about it. Thanks for putting this on.
Hi there, dear audience. Well, querida audiencia, I want to introduce you Professor Joel Meyerson. Okay. Well, Professor Joel Meyerson conducts research on behavioral economics, focusing on individual choice and the discounting of delayed and probabilistic outcomes. Another research area of Dr. Meyerson is cognitive aging, focusing on age differences in information processing, working memory, speed of processing. He's a prolific researcher. He has written more than 100 articles. His work has been cited almost 18,000 times. Professor Joel Meyerson, thank you so much for your time, for giving us the opportunity to learn from you. Professor Joel Meyerson recorded his presentation. Ok, now in Spanish, queremos presentarles al doctor Joel Meyerson, profesor Joel Meyerson. Él lleva a cabo una investigación sobre economía conductual, se centra en la elección individual y la evaluación psicológica de resultados demorados y probabilísticos, elecciones intertemporales y bajo riesgo. Otra área importante del Dr. Meyerson es el estudio de envejecimiento cognitivo, se centra en las diferencias de edad, en velocidad del procesamiento de la información y memoria de trabajo. Es muy prolífico el Dr. Meyerson, ha escrito más de 100 artículos, su trabajo ha sido citado 18,000 veces. Y pues, doctor Joel Meyerson, muchas gracias por darnos la oportunidad de aprender de usted, por el tiempo que se dedicó a hacernos esta presentación que pues grabó para nosotros y esperemos se conecte para que tengamos tiempo de hacerle algunas preguntas, porque el doctor tiene una dificultad auditiva y entonces, pues bueno, él prefirió como para que fluyera más la presentación. Pues muchísimas gracias. Adelante, Lauren, para que hagas la presentación del video del doctor.
Hi, I'm Joel Meyerson, and welcome to my talk. I'm an experimental psychologist by training, actually trained by Peter Kalinin, who you may have heard earlier today. And I do research, or I have been doing research primarily in two areas, one of which is the choice and decision making, which Peter would not be uncomfortable with my doing. And the other is cognitive aging. And I'm not sure how he quite feels about that. But actually lately I've been studying the pandemic and the effect that it's been having on people. And that sort of makes me a quasi-experimental psychologist. But here's the title of my talk, The Effects of Age, Depression, and Anxiety on Pandemic Mitigation Behavior. We have a grant from the National Institute on Aging to study, actually the grant was originally in response to a call for proposal on behavioral economics and aging. And that's what I thought I was going to be doing. And then along came the pandemic. So we have collaborators, my co-investigator on the grant are Mike Studi, Greg Green, and my wife from college, Sandy Hale, also economics. And special thanks to Tanya Waldeyer, who's our lab deputy doing this, and shortly, she has been our lab deputy, and actually So we have responsibility for collecting the data and for a lot of the risk analyses that I'm going to be talking about today. And where we call it why graduate students about behavior. Special thanks to Tanya Waldeiler, who's at the lab that is doing and actually so we have responsibility for collecting the data and for a lot of the risk analyses that I'm going to be talking about today. And where we call it why. Final dissertation defense next week, and he's the one who sort of got me started studying the pandemic, mainly by pointing out the problems of studying decision making during the pandemic when the pandemic may be altering people's decision making. So I sort of decided, well, okay, let's study that. Let's study probably some of the most important decisions that people make during the pandemic. And those have to do with mitigation behaviors, things they can do to decrease the risk that they're subject to. The data that you read in the newspaper and elsewhere can be somewhat a little confusing. Mainly, you can blame the reporters who do it, but they would often talk about the case counts. And the problem with the case counts is if you look at how they change as a function of age, you see the number of cases in the different age cohorts goes down, as if people were less susceptible to the pandemic as they got older. On the other hand, that doesn't really seem right. And it's not. I mean, the total number of cases is important if you're managing a hospital. And for other kinds of applications, it can be an important number. But really, it can also give you the wrong idea because, in fact, the number of people in these age cohorts are different. And if you correct for that, if you correct for that, so you're looking at the case rates, the number of cases divided by the number of people in an age cohort, you can see that really it remains pretty much flat from about age 50 on. Now, it is higher initially, and why that's so, since there's no reason to think that younger adults are more susceptible to the virus, is really perhaps related to the mitigation behaviors that we're going to talk about. You see the same kind of issue come up when you look at deaths. So if you look at the total number, you see, more older people are dying. But if you correct for the number of people in each age group in St. Louis, you see that the increase in death rates is really quite pronounced. And I'm using these data from St. Louis because our public health department here has a very nice dashboard, and it's easy to get these things. But we're talking about things that are presumably much more general. There's a study cited at the bottom of the page by Williamson et al. It was done in England, looking at all the COVID-19 patients that were treated as part of the National Health Service in Britain, and that's over 17 million people. And basically, you find the same thing, that one of the strongest predictors of mortality, that is, of susceptibility to severe complications from the virus infection, is age. So that makes this whole topic of aging and the pandemic and mitigation behaviors really quite important. And the way that we went about studying this was by making up a questionnaire. We couldn't bring people into the lab, not during the pandemic, but we can study people online, and we can do that by making up a questionnaire that then is administered online. So we asked people about various behaviors and asked them how often did they do this past week? How often did they do it several months ago? Actually, when we say how often this past week, these questions were asked in about the middle of April, sort of the peak of the first surge. And therefore, several months ago was really before the pandemic. And what we were most interested in was the mitigation behaviors that were recommended by the CDC, which is the United States Centers for Disease Control and Prevention. And they recommend two kinds of things. Things that you should do, thou shalt, and things that you shouldn't do, thou shalt not. And the thou shalt are really mostly hygiene measures. Washing your hands, disinfecting the surfaces in your house. And for these kinds of things, doing them more often is better. So the thou shalt nots, these are really the social distancing kinds of measures. Being closer than 6 feet to someone who's not in your household. Actually having physical contact with someone not in your household. So these kinds of things, less is more. And this is important when we look at the data, because there are some things where it's good if the measure goes up, and for other things, it's good if the measure goes down. Or if we're looking at correlations, the sign will change from negative to positive as we go from the distancing measures to the hygiene measures. So, in addition to asking people how often they did things recently and several months ago, we asked them about things that we thought were potential predictors of the mitigation behaviors. This was really kind of a fishing expedition. We had asked about the usual suspects, but the good news is that the story we end up being able to tell is relatively simple and I think relatively important. But so we asked people their age, we asked them to rate their health, how much education they had, what their income is, both individual income and household income. and how concerned they were about the effects of the pandemic on themselves and about the possible effects of the pandemic on other people. In addition, we asked them about anxiety and depression using the hospital anxiety and depression scale. So more on those, and we'll come back to this in a minute. But we're really interested in things like who engages in mitigation behavior. We got what for us as experimental psychologists it was a large sample that we could do so online. And we got people across a fairly wide age range. We did this by posting 2 hits. One of them was for people of any age. And then to beef up our older adult sample, we posted another one for people 55 and older. And the timing of this study is also kind of important. Because we recruited people for our study in April, when, as I said, it was sort of the peak of that first surge, but also the states of the United States of America were generally under lockdown. The specifics varied from state to state, and the way that it was enforced varied from state to state. But there was a general agreement that people should be staying at home. So we didn't have to worry too much about geographical variations adding noise to our data. And the first thing that we found out, and that you see here, is that people did, engage in mitigation behaviors. You can look, the light gray bars are, the frequency with people on average said they did things before the pandemic, and the black bars are frequencies done during the pandemic. As you can see, for the social distancing, the frequencies decline, and declined a lot. This is a good thing, right? For the hygiene behaviors, things went up. The frequency of things like washing your hands and disinfecting surfaces at home increased, but not nearly as much. And but all these changes were statistically significant. And we've got a lot of power, of course, with all these participants. But nonetheless, it's reassuring to know that things were moving in the right direction. In the meantime, home hygiene has become less important as a mitigation behavior. If people have found out more about how long the virus survives on different kinds of surfaces, and hand hygiene, on the other hand, we probably didn't ask the question quite right. And then also, in fact, the CDC has changed the specifics of its recommendations. But just looking at how often people wash their hands, people wash their hands for lots of reasons, lots of times during a day. They wash before and after they eat. They wash when they use the bathroom. and people vary in the extent to which they do things. So this is basically a very noisy measure, and we're doing follow-up studies now, and we've changed the way that we ask it. So we're really asking things like, well, you wash your hands whenever you come home. That seems to be a much more relevant kind of information, business information to get from them, rather than how many times if you're staying at home, which is a good thing, how many times a day do you wash your hands while you're staying at home? Not necessarily all that relevant to anything. So that was looking at everybody. If we now start to break things down by age, we can really see the age trend. And what's happening here is that we're looking at changes, and we're looking at changes because everybody starts with a different baseline. That depends on who they are and their lifestyle and their job and a lot of other things that we're not interested in. So although they might ultimately turn out to be important, but for now we just want to know who's moving in the right direction, which is down. And when it comes to social distancing, and how much are they doing so? And you can see that the older adults, regardless of whether they start higher or lower, are changing more. That is, their change is a more negative number, which is why it's going down when the change is actually larger. But we see changing with age, but interestingly, it's also independent of how people rate their health or their concern for themselves, how the pandemic might affect them. Now, this is especially important in figuring out what older adults are up to because their health is poor. And if they were really worried about themselves, if that was the reason why they're showing more change in their mitigation behaviors, that would be one thing. But it turns out that a lot of change in social distancing is really independent of oneself, and at least consistent with that, it's also independent of one's concern for oneself, for how the pandemic could affect you. So here we're looking at the size of the change. The other way to look at it is to see how likely people are to change in the right direction. And it's converging evidence that the older adults really are behaving more appropriately than the younger ones. Here we've pitted those in their 60s and 70s from those in their 20s and 30s. And although everybody, is more likely to decrease the frequency of these behaviors, which is desirable, the older adults are more likely. So they are more likely to show adaptive changes in mitigation, and when they do change, they change by a larger amount. One way to look at this, which turns out to be quite useful, is to look at the correlation. Because as you probably saw on previous slide, we're really asking people for categorical responses. one category is daily, and another category is every other day. But the differences between these different categories is not constant. Just on guesses as to what would work out well in terms of data collection, and so that affects the kinds of analyses that we do. And so we're looking at Spearman's row here, and because for lots of these things we're asking the same basic question over and over again. Does social distancing change with age? Does social distancing change with health? Does social distancing change with concern for oneself? We do a Bartheloni correction to correct the sort of the likelihood of getting what would otherwise appear to be a significant result. And what we see is sort of consistent with what we saw previously, that social distancing, both decreases in proximity, or let's say, yes, and decreases in the frequency with which one has close encounters, and the sense to which how often people have physical contact with other people outside their house. These things are going down with age. The one thing that also seems to predict it is people's concern for others. Not so much their concern about the effects of the pandemic on themselves, but for how the pandemic might affect other people. We didn't ask them which specific others they were concerned about. It could be just the general community. It could be people in their family. But the important thing is the reason why social distancing increases, that is, people decrease the frequency of close encounters and things. Why that changes with age is not because people are worried about themselves and their health, or because of other concerns about themselves. Concern for others is a more altruistic kind of motivation, and it seems to be a more important one here. When we look at other kinds of demographic potential predictors, individual income is not a predictor of mitigation behavior, nor is the amount of education people have gotten. It suggests that social distancing is not affected by one's socioeconomic status, which would go along with their individual income and their educational level, but it is affected by their household income, which says that it really is more about the financial resources that they have available to them, regardless of where they come from, regardless of whether they're earning this money themselves or other people in their household are earning it. So household income predicts social distancing, but individual income does not. When we sort of wind up thinking about what all these things mean when we put them together, that one may turn out to be important. So we also looked at the correlations of their mitigation behaviors with their current psychological state. And here we see that these are really the strongest predictors of mitigation behavior. How depressed people report feeling, how anxious they report feeling. Although we saw, significant correlations that, survive bond flowing correction, with some other predictors, these correlations are really much stronger. And suggest that one's, psychological state, how much stress you're under, is probably very important. And so the question then becomes for us, well, does this explain perhaps the age differences in the mitigation behaviors? Because there are age differences in anxiety and depression. These are fairly well established, not in every study, but in general, this is what you see. And this shows, the changes in anxiety and depression in our own data. We said we used this hospital anxiety and depression scale because it's primarily a state measure, not a trait measure. What traits predict mitigation behaviors is another very interesting question. But that those kinds a trait by definition is going to remain relatively constant whether it is a pandemic or not. But their state anxiety is going to go up, and the likelihood of the depression, being depressed, is going to go up. One other nice thing about the HAGS, the Hospital Anxiety and Depression Scale, is that there are cutoffs that can be used above, so there's scores above which you would suspect that people actually have a disorder. They have an anxiety disorder or depressive disorder, and we can use these caseness, as they call them, cutoffs, in further analysis to try and get at the role of anxiety and depression in mitigation behavior. So what we've done here is we're plotting the change in mitigation behavior. That is, to what extent the frequency of close contacts goes down, or close encounters. If we look at the sample as a whole, and there you see, this is what we've seen before, that these behaviors decrease. Now we can throw out everybody who's above the cutoff. So we're going to get rid of the more severe cases of anxiety and depression, and see what happens. And as you can see, when we do that, we go from white dots to gray dots, and the frequency with which people are getting close to one another or contacting one another goes down even further. And what that suggests is that the numbers, that the frequencies were as high as they were, even though they, even for young adults, were on average, low. Because we are in a sense controlled then for depression and anxiety. When we pick out somebody who's a case, we mean somebody who was above the threshold for either an anxiety disorder or a depressive disorder, or both. And the correlations with age, these low values that we see, also drop quite a bit. Suggesting that, yes, a lot of the reason why people weren't showing more mitigation was because the really anxious and really depressive ones were keeping those frequencies up relatively higher than they would be otherwise. Now, there's still, a relationship, but you can see that the decreases when the changes that we throw out the cases are much larger for young adults and relatively small when we get to the two oldest age cohorts. So they have, in fact, less cases that were excluded, and that it explains to a fairly large extent, I think, why young adults don't show as much social distancing as older adults. It's because the younger adults are much more psychological stress for as a result of the pandemic than the older ones are. Now, why younger adults are more affected by the pandemic than older adults psychologically is an interesting question. But that's really not the question that we're trying to get at. We're trying to get at, why, it's sort of the flip side of the question, why are older adults doing more of what they should, according to the CDC? And along with it, why are the younger adults doing less? And anxiety and depression seem to have a lot to do with it. Our results have a number of implications for basically for public health. And one of the implications is, as it says there, beware fear messages. Now, fear messages are a traditional public health approach to changing behavior. And basically they say, engage in this healthy behavior or else something awful is going to happen to you. Or don't engage in this unhealthy behavior or else something awful is going to happen to you. Now, such messages can be effective, which is why there is this traditional approach. But they're especially effective when promoting one-time behaviors, like, for example, vaccination, which people are going to be promoting, and which, perhaps to my surprise, are going to require a lot of promotion. But the other thing that fear messages require to be effective is that the efficacy of what you're recommending is clearly established. The problem here, first, as I said, is that most of the mitigation behaviors that are needed in the current pandemic are not one-time events. They're really patterns of behavior that are going to have to be maintained for quite a while yet. And there have been conflicting messages as to their efficacy. Some of them coming from the President of the United States and even some people on his pandemic task force. So these are the kinds of things that undermine the effectiveness of fear messages. But the present findings suggest that there's another reason why they're probably not a good idea to use, at least exclusively, and perhaps not very much at all. It's because the way they motivate behavior is by increasing anxiety, right? You should be anxious about the or else unless you engage in a particular behavior. Or you should be anxious unless you refrain from engaging in some other behavior. I'm finding suggest that the last thing you want to do is raise people's level of anxiety. That when you do, in fact, it decreases their tendency to engage in appropriate mitigation behaviors. Increases anxiety. It can also increase depression. So, not such a good idea. So the question is, well, all right, so what do we do instead? And our findings suggest a couple of alternatives. One of them is to actually promote concern for the effects of the pandemic on others. Concern for others.
Hi there, Felipe. We are backstage.
A prediction of appropriate mitigation behavior.
Hola, aquí esperando que acabe la conferencia del doctor.
Okay,
Unos segunditos.
It's concern for the effects of the pandemic on others. There are a few studies that have tried using this kind of approach and messaging approach, and they suggest that it does work. That you want people learning about their community, and what's going to happen to the other people in it. That can be an effective way to motivate them to do things that will not only protect their community, but protect themselves too. But you don't necessarily want to present it that way. Another thing that can be done is providing financial support. That's sort of what we, basically the finding what's implied by the effect of household income. Now, at least in the United States, promoting this idea may call for some public health message of its own, because the idea that we're going to give people money is not generally considered a good thing by some people. But the important thing I think to stress is that if you do this kind of thing, if you increase the household income, the goal is not necessarily to help the people who you're giving the money to. It's an investment in public health. You're getting new money because it's good for everyone. That hopefully may make it more politically acceptable, which would be a good thing. And as I said, both of these approaches, promoting concern for others and somehow increasing household income, are things that are associated with greater compliance with the CDC recommendations. Now, also, I should point out that holding virtual meetings like this one is a good thing. It's the way to hold meetings, and also it's a good thing. You're listening to other people's talks and enjoying it. It'd be nice if we could go for drinks afterwards, but even without it, this is a good thing. So we need to be creative about thinking of the things that we can do and the changes in our lives. And now, when we did this, the notion of wearing masks was not widely accepted. Everybody, sort of agreed that the doctors and nurses should be wearing masks. But whether they would work on a larger scale and whether they would protect the individual mask wearer was really much more open to question, still somewhat open to question, but things that have changed a lot in the pro-mask direction. So, wearing your mask, we're asking about mask wearing in our follow-up studies. Now that the CDC is recommending it for everyone, and hopefully we do all these things, we'll all have a happy and safe New Year. Thanks very much for paying attention here, and I hope that's what you were doing. I'm not going to take any questions. I have hearing problems, and somehow Zooming and other things really don't provide the kind of auditory input that I can use effectively. So instead, here's my email address and my cell phone number. So if you have questions, objections, comments, or thoughts on anything relevant, or you just want to plan what we're going to do next year, send me an email or send me a text. And especially if you send me a text, I will call it right back. So thanks much, and hope to see you again soon.
Escucho el sonido, un segundo. I'm sorry. Un segundo. Tengo un problema con la pantalla. Tengo una retroalimentación aquí en el screen. I'm sorry. I have a problem. I have a problem with my screen. Wait a second. Hi again. I'm back. We have a problem with my computer. Okay. Thank you, dear Joel. Thank you so much for your presentation. It was quite interesting. All the effects of demographic variables and mitigation behavior during this pandemic situation, especially for public politics in health. I think that's really, really important, all that findings. We will send you all our reflections and concerns about it. And thank you so much. En Spanish, querido Joel, muchísimas gracias por tu presentación. Fue bastante interesante los efectos de todas estas variables demográficas, incluyendo la sintomatología depresiva y ansiosa sobre este comportamiento, bueno, comportamientos de mitigación durante esta pandemia. Creo que esas reflexiones nos permiten mejorar las políticas públicas en salud y pues bueno, te vamos a mandar todas nuestras reflexiones, inquietudes que surjan y estamos como muy atentos al chat para esto. Sorry for all the interference during the talk. We are going to record it again to be able for you without all that interference. Vamos a ver cómo la volvemos a grabar para que la tengan disponible sin toda la interferencia que hubo durante su presentación. Well, it's time for the next speaker. Okay, Alejandro.
Gracias, Diana. Bueno, I hope everyone enjoyed the great talk for Dr. Joel Meyerson. Unfortunately, we had a technical problem, but as Diana told everyone, we're going to try to work on this and send it to you, and so you can enjoy the talk of Dr. Joel. Even if you have questions or anything about the presentation of Dr. Joel, please send us, and we're going to resend it to Dr. Joel, so you're going to have the answer in a proper time. Well, again, remember that it's very important to fill out the Google form in order to obtain the certificate of attendance. I already posted on Facebook, Twitter, and YouTube. Anyway, it's time to continue with this series of incredible talks, and now it's the turn of a friend and a Colombian colleague, Dr. Felipe Parrado. For those who don't know Felipe, he has a degree in psychology from the National University of Colombia in Bogota. He has a specialty in consumer psychology from the Conrad Lawrence University Foundation in Bogota, Colombia. He has a master's degree in advanced studies in brain and behavior from the University of Seville in Spain. He recently graduated from the doctorate program in behavioral sciences from the University of Guadalajara in Mexico. He's currently assistant professor of the psychology program of the Sur Colombiana University, and he teaches multiple courses such as research design, psychobiology, behaviorism, sensation, perception, thought, and language. Today we will have the pleasure of listening to his presentation entitled "A Place and Time for Everything: The Importance of Learning Innovation for the Differentiation of Responses." Now I will do Felipe's